start the session. So I have planned something. So let's see how far I can go. Okay, so so whether my screen is visible?
Yes, sir.
Yes, sir.
Okay, fine. Okay, so let's start with the definition of limit of a sequence. So okay, so before that, let me remind you that sequence is basically it's a function from the set of natural number to R. Okay, so sequence is nothing but it's a function from the set of natural number to R. Okay, so that is the definition of sequence. So next, come to this limit of a sequence. So suppose you have a sequence AN, right? So you have a sequence AN. So when you can say that this sequence has a limit which is basically A. Okay, so when you can say that the sequence has a limit A. So if you increase the value of n, okay, if you increase the value of n, then the value of an will come closer and closer to A, right? So once you increase the value of n, then the value of an will come and closer to A. So then you say that the sequence an has a limit A. Okay, so in that case, so when you have a sequence and that sequence has a limit, then you say that sequence an to be a convergent sequence. Okay, right? So when a sequence has a limit, at that case you say that sequence is a convergent sequence. When if you increase the value of n, and what you observe that the value of an is not coming closer and closer to any value. Okay, in that case you say the sequence is divergent. Okay, for example, if you take this sequence an, let's say this is my sequence. So this is my sequence. How I define this sequence? This sequence is -1 to power n. Okay, so if I increase the value of n, then this an will oscillate in between -1 and 1. Okay, so it's not getting closer to any particular number. Okay, it's basically oscillates in between -1 and 1. So that's why this sequence don't have any limit. Okay, this is a divergent sequence, right? Okay, and if I consider this sequence, so instead of this sequence, if I consider this sequence, as you can see, if I increase the value of n, so if I increase the value of n, then this value, the value of the sequence will come closer and closer to 0, right?
So, yes, sir.
Okay, so this sequence goes on. So if I increase the value of n, this sequence will come closer and closer to n. So that means this sequence has a limit, and the limit of the sequence is nothing but 0. Right, so this is a convergent sequence and this is a divergent sequence. Okay, so let's go to few examples. Okay, so any idea what will be the limit of this sequence? Question number 1.
3 by 4.
3
by 4.
3 by 4.
3 by 4.
Yeah, so any idea how we should
divide by n square?
We need to divide
Yes,
by n square.
Correct.
Divide by n square, numerator and denominator both.
Correct. So the best way, okay, let me repeat. So all of you are correct. So this is my sequence. This is the nth term of my sequence, right? So what I'll do, I'll divide this n square with both numerator and denominator. Okay, so once I divide, this will become 5 by n plus 2 by n square, and divided by 4 plus 2 by n and 1 by n square. And you know, as n tends to infinity, 1 by n will go towards 0. So
Zero.
yes, and similarly 1 by n square also come closer and closer to 0. Okay, so if you increase the value of n, so for example in this expression, if you increase the value of n, this will go towards 0, this will also go towards 0, and 2 by n also will go towards 0, and this will also go towards 0. So basically you are left with 3 by 4, right? So that means this is a convergent sequence, and the limit of this sequence is 3 by 4. Okay, so what about the second one?
That does not.
Zero, I think.
Infinity.
0.
1, 0.
So someone said infinity. I just want to know why. And I guess someone said
Sir,
1.
There is no upper bound.
Because-
It will go
Sir,
on.
it is indeterminate form, no? Infinity minus infinity is indeterminate form.
No, it's not. Okay, so now it's not in the form of infinity by infinity, right? Because you have a minus. Okay, so you don't know what is infinity minus infinity, right? So it can be 0 also, right? See, for example, if I take this sequence,
Infinite
n,
minus infinite is in indeterminate form.
so suppose you take this sequence, right? N plus 1 minus n, right? This is a
Yes, sir.
sequence, correct? So now this part goes towards infinity, right?
Sir,
And this part also goes towards
Infinite.
infinity.
Infinity.
So what is the limit of this sequence?
1.
1. But okay, so then it should be, so according to your rule, this should be also infinity, right? But this is not infinity. You are getting, so this is basically 1. Okay.
So we can calculate this.
Yeah, so simply by looking at, if it is something like infinity minus infinity, then certainly you cannot say that it will go towards infinity. If it is in the form of infinity plus infinity, then you can blindly say that okay, it will go towards infinity. Okay, because you don't have any barrier, because you have both positive infinity. Okay, but when you have infinity, like when n tends to infinity, this will go towards infinity, and also as n tends to infinity, this will also go towards infinity. But the problem is here you have a minus sign. Okay, you don't have a positive sign, so you don't know what will happen to the whole term. Okay, so what we will do now? We'll try to rewrite this sequence in a nicer form. Okay, so what we'll do, we'll multiply. So this is my sequence. What I'll do now, I'll multiply 2n square root of 2n plus 1 plus square root of 2n divided by square root of 2n plus 1. So basically I'm not doing anything else. I'm just multiplying this sequence with 1. Okay, so this is 1. Okay, so basically I'm getting the same sequence. So what will happen to this numerator? What I will get in the numerator?
2n plus 1 minus 2n.
1.
Correct. So this is 2n minus 2n plus 1 minus 2n. Right? So I can cancel this out. So finally what I will get 1, right?
Yes, sir.
Yes.
So now can you tell me what will be the limit of the sequence?
0.
Because now
0.
N tends to 0.
now if you see,
1 by 2 root 2.
sorry,
1 by 2 root 2.
no, it's why is 1 by 2 root 2?
It will be 0, sir.
Yeah, so because now as you can see, now we are in a safer condition. If you see in the denominator, we have infinity plus infinity, right? as n tends to infinity, this if you see this term in the denominator, only in the denominator. So this is basically infinity plus infinity, right? So that means that the sequence in the denominator will diverge towards infinity, right? That means if I take 1 by something large, then I should get very small, right? That means this will converge
0.
towards 0. Okay. Is it clear?
Yes.
Okay. Okay, let's go to the next question. So what is, suppose you have a sequence. So some sequence, so the sequence is slightly tricky. So this sequence, you have a sequence an, and how you define this sequence? The sequence an is nothing but n power 1 by n, right? And somehow you know that the limit of this sequence, okay, somehow you know that this limit of this sequence is 1, right? Somehow you know that this limit of the sequence is 1. So as you can see, this sequence is nothing but the first term of the sequence is 1, the second term of the sequence is 2 power 1 by 2, the third term of the sequence is 3 power 1 by 3, and the fourth term of the sequence is 4 power 1 by 4. Okay, so so somehow you know that the limit of the sequence is 1, right? This is what you know. Okay, so now using this fact, you need to compute the limit of the sequence that are given in these 4 options. Okay, so so what will be the limit of the of this sequence? What will be the limit of this sequence? Limit n tends to infinity, ln of n power 1 by n.
0.
Why?
So n power 1 by n tends to 1. So ln of 1 will tend to 0.
So the nicer thing about this logarithm function is basically you can take this limit inside. So what you can write, so instead of writing this, you can write what you can write. You can write ln of limit n tends to infinity, n power 1 by n. So, but you know, so from the given given information, you know that limit of this sequence is 1. So finally you have ln of 1, which is 0. Okay, so that means so this option 1 is correct. Okay, and what about the second option? How
correct, sir, because first one is wrong.
correct? So yeah,
If first
The limit of
given
second function
it will
is
be
1.
ln of
so what I can do now, so similarly using the same rule,
ln of
I can take this limit inside. So this is basically limit n tends to infinity 1 plus n power 1 by n. So now next what I need to do, I need to use the additive property of limit, right? So this limit is nothing but limit
1 plus limit n of
correct. And this limit is certainly 1. Okay, this is 1. And from the given information, I know this is also 1. So the final thing is basically ln of
that is ln of
2. Okay, so that means
which
second
can't be 0.
correct. Yeah, so that means second option is incorrect. Okay, let's go to the third option. So what is option
It is
3?
correct, sir.
Yeah, probably let me
Correct,
check.
sir.
Yeah, so let me go to the third option. So the third option says limit n tends to infinity ln 2 minus 1 by n. Okay, so ln 2 minus 1 by n divided by ln of 1 plus n power 1 by, right? So I know what.
Denominator we have already calculated as
Yes, so we have already calculated the limit of the denominator, okay, which is basically 2, right? Sorry, ln2. So this is ln2.
ln of
Yes, ln2, And what will be the limit of the denominator? So this is, so you have
ln.
1 by n here. So
This will
will
tend to 0.
0, correct.
Zero.
So then you have ln2 by ln2, which is nothing but
1.
1.
And okay, let me do it. Let me directly do here. So what will be the limit of this sequence? The sequence which is given in the option 4.
It is correct, sir.
Correct, right? Because again, the same rule. I'm just applying the same rule again
You
and
can
again.
split it like this: 1 by n to the power 1 by n whole cube. Then 4 into 1 to the power whole cube is 4. 4 minus 1 is
Correct. Yeah, absolutely.
3.
Correct. N tends to infinity, and I know this is
It
basically
is 1 upon n.
sorry, yeah, correct. So I know this limit is 1. Okay, so this is precisely 4 minus 1, which is, sorry, 3. Okay, so that means option 3 is correct, and as well as option 4 is also correct. Okay. Okay, so let's go to any doubt? Whatever I have discussed till now, do you have any
No,
doubt?
sir.
Okay, fine.
No.
Can you do the same with trigonometry also? Means trigonometric functions.
Okay,
Define
so
sequence.
Yes, sir. Can you show the formulas?
formula, like which formula you are asking? Sorry.
So there are 3-4 formulas given as hints.
So can you repeat all the basic formula ones, like the limit n raised to the power 1 by n?
But we have mentioned all these things in
Can you just repeat, like show it once?
in solve with us assignment. Like I have to
Okay,
go
okay.
to the portal and I have to open it. Okay, so
Okay, sir.
yeah. Okay, we'll just remind me in the end. Maybe probably I can go through it again. Okay.
Okay, sir.
Okay, so so the next thing is limit of a function. Okay, so okay, so before going into the limit of the functions, so one of you wants
Excuse
to.
me, sir.
Yes.
I was asking about means calculating limit on any trigonometric functions. Means can you solve one question using that? Take one random question.
Okay, let me take one random question. Let's say which one you
Will
like.
help.
Sir, can you show some important formulas for limits?
So there is no formula for limits. Okay, you don't have to. If you practice enough problem, then you really don't have to remember anything for limits.
No, sir, for sequences, those convergent, divergent.
Same goes for sequences also. Like if you practice enough problem, then you really don't have to remember anything. So so suppose let's say let me take some example. I really don't remember any of your activity question. Let's say you have a sequence like this. Let's say you have a sequence like this. Limit n tends to infinity. Sine n. What will be the limit of this sequence? Hello.
Sine n. Then
0.
Sorry.
minus 1 to 1.
Minus cos n?
That will be the range.
Minus 1 to 1.
No limit. No limit.
No, limit
Sir, no
cannot be
limit, because-
limit cannot be -1 to 1. Limit has to be a unique number. Okay, it cannot be certainly -1 to 1. Okay.
Sir, n it will be n.
It would be sir oscillating between 1 and -1.
It should be
Does not exist.
Yes. So the limit is basically doesn't exist.
does not exist.
Because it oscillates between 1 and -1.
Correct. So if you draw the
Yes.
graph, basically if you draw the graph, so it's basically oscillate in between -1 to 1. Okay. So
Yes.
then you will get some number, repeating number in between -1 to 1 again and again. Okay, so that's why this limit of this function is basically limit of this sequence doesn't exist. Okay, so let me change this sequence. Let me make this sequence into something like this.
In question, if you are asking only limit, then we have to calculate tends to infinity or 0.
So limit of a sequence. So how you compute limit? How you compute limit of a sequence? So for the sequence, you have to always take as n tends to infinity. Then this is by definition, right?
Okay.
Limit of a sequence and limit of a function is different. Okay, so when I'm talking about limit of a sequence, then you have to always take this n towards infinity. Okay. Okay, so then what will be the limit of this sequence? Sine n
1.
0.
0, sir.
0.
I think it's 1.
Why it's 0?
Sir, because
Sir,
sine, because the value of sine is varying from -1 to 1 and n is tending to infinite. So basically the
So
maximum
1
value
upon
of-
n will
so
tend
maximum
towards
value
0.
of sine n is
That's
equal
why
to
0
1.
multiplied by sine.
Okay, so yeah, so I guess it's correct. It's more or less correct. So the better way to see it, basically this sandwich thing. Okay, so you have sine n, right?
Yes, sir.
So you have sine n, and you know that sine n is basically in between.
-1 to 1.
It's basically less than 1, and it's always greater than -1, right?
Yes.
So what you want? So instead of sine n, what you want? You want sine n by n, right? So
Divide by n.
So what we have to do? We have to divide by n, right? Both in all these three terms, we need to divide by n. Okay. Correct?
Yes, sir.
So now what we want to know? We want to know limit of this sequence, which is in the middle, right?
Yes, sir.
So which is it seems slightly complicated, but for us, it's really easy to compute the limit of this one, right? This 1 by n.
Yes.
And we also, for us, it's also easy to compute the limit of this sequence, -1 by n. So limit of this sequence is 0, and limit of this sequence is 0. And then
Is also 0.
by sandwich lemma, you can say that limit of this sequence is also 0. Okay.
So 0.
Yeah. So because as someone already said, sine x is basically it's a bounded thing. It's oscillate in between -1 to 1. And if you increase the value of n, the value sine x, the function which is in the denominator, in the numerator, it's basically in between -1 to 1. But the term in the denominator, it's diverges towards to infinity. So something bounded by infinity is always 0. Okay.
And what about sine n pi by n or n pi plus 1 by n?
Can you repeat sine?
N pi by n.
Again, see, it doesn't matter. Okay, like so whatever maybe you have here, whatever is there, it's always, so it will be always less than equal
-1 to 1. -1 to 1.
It cannot go beyond this interval, -1 to 1. Okay.
Okay. So any value can be within that sign, and it will always.
So can we say this as a convergent, sir? Then
Yes. So instead of, suppose you have something like this, let's say you don't have something like this. Let's say you have something like this. Instead of sine, you have sine n square plus n plus 1 plus 100 plus maybe say.
Sir, is sine interval -1 to 1, sine interval is -1.
something like this. Okay, it also doesn't matter because the value, see, the value of sin x, it cannot go beyond of this interval -1 to 1. Okay, and as n tends to infinity, this thing whatever is there, it will always lie in this interval. But as n tends to infinity, this n, it will go towards infinity.
Yes.
So eventually this whole thing has to go towards 0. And the same trick you can apply for cos also, right?
Sir.
Because cos is also a bounded thing. It's basically it's in between -1 to 1, correct?
Sir.
Okay.
Yes.
Okay, fine.
And tan?
Cos also, sir? So same,
Yes,
same interval.
Yeah, same.
Tan theta, sir?
Tan you can't apply the same thing on tan function. Okay, you have to be very careful while doing the tan thing. Okay.
Sir, what about n tends to 0?
1.
N cannot. Why you want to take n towards 0? N is a natural number. How you will take towards 0?
Sir, question has come in the last quiz.
Yes,
No,
sir. In quiz 2, there was
that
a
is no. That is a different question. Don't mix limit of a function with the limit of a sequence. Okay. So I think some question came, but that whatever you are asking, that is related to limit of a function, not limit of a sequence. First try to understand the difference between limit of a sequence and limit of a function. Okay, limit of a function, you can compute the limit of a function at any point. Okay, but by definition, limit of a sequence, what basically we have defined here, you need to check what is the value of this sequence, where this an is going. If you take this n towards infinity. Okay, so how you can take this n towards 0? That is not included in the definition. So in the definition, what you need to check? You need to check where this an approaches as n towards infinity. Okay, so you have to always take this n towards infinity. You can't take n towards 0. This is not allowed when you are computing limit of a sequence. Okay, you can, so for function, that is something different. Okay, is it clear?
Sir, one doubt. Sir, what is the maximum value of sin n pi plus cos n pi?
Is it related to sequence?
Sir, while finding sequence, limit of a sequence, we can use that.
Is it related to the what? So
like sin n pi value different from -1 to 1.
No, see, the thing is, again you are asking some irrelevant question here. Okay, so the thing is, now I am discussing about limit of a sequence. Now what you are doing, you are asking limit of like maxima and minima value of a function. Okay, you are asking the this one, like sin
n pi plus cos n pi.
What can be the maximum value of this sequence? You tell. Sorry,
I think between -1 to 1.
no, this is certainly, see this
-2 and 2.
Because
this is certainly less than equal to 1, and this is certainly less than equal to 1. Okay, so very easily we can say that this is certainly less than equal to 2. Okay,
Yeah.
but the thing is, okay, when when sin is 1, at that time cos is 0, right?
sir, sin pi is 0 na, sir?
Sorry.
Yes. N pi equal to 0. Will be by.
Yeah, so the thing is, no, what I'm saying, okay, let me come to that thing. Okay, so this, we know that sin x is always less than 1 and cos x is always less than 1, right? And by using that, I can blindly say that this one is certainly less than 2, right? But
Yes,
the
sir.
thing is, when sine is 0, cos is basically what? It can be
1.
1, or maybe I guess it can be also -1. Okay. And at the same time, when cos
n is same.
Sorry, n is no. I'm so n.
We are
n,
taking n variable n equals to 0. It means we are having sine 0 and cos 0.
No, n varies over natural numbers. Okay, so this n can be 2, n can be 3, n can be 10, n can be 100.
Yeah. It can be anything, but
Yeah.
I'm assuming a case.
No, you can't assume, because according to the question, you cannot assume any specific value of n. Okay, because n varies over the set of natural. So the thing is, if this is basically 0, okay, and this is basically 1 and -1. Okay, so in this case, the maximum value this sequence can achieve is 1. Okay, clear?
Yes, sir.
Yes.
Yes.
Won't it be root 2?
Sorry.
I think it should be root 2 when, like,
Okay, I'll suggest please try to go and check the values of sine n pi. Okay, because at multiples of pi, sine is always 0. Okay.
Sir, please proceed further.
Yes. Okay, so okay, so the next thing is limit. Okay, so how you check the limit of a function? Anyone?
Left hand limit should be equal to right hand limit.
Correct. So to know whether a function has a limit at some point a. So, okay, so to know whether this function, suppose you have a function, to check whether this function has a limit at point a, what you need to do, you need to do two things. Okay.
RHL equal to LHL.
Correct. So you need to find the left
RHL.
hand limit.
Yes.
Yeah,
LHL.
left hand limit.
And RHL. Right.
And you need to find the right hand limit. Okay.
If both are equal, then limit exists. Otherwise, does not exist.
Okay. So this is, I'll denote this by this one thing, and this is my right hand limit. So when the left hand limit and right hand limit they matches, then you can say that limit of this function at point A exists, and the limit is precisely this one. Okay. So when the limit left hand limit and right hand limit at a point matches, then you say that the limit of the function at x equal to 0 exist, and the limit of the function is nothing but this one. Okay.
Sir, excuse me, sir. Sir, the value of a could be any value from the given graph of a function.
Correct. It can be anything, right? So because so even if a is not in the domain of the function, okay, even if a is not in the domain of the function, still you can talk about the limit of that function at that point A.
Okay, sir. Thank you.
Yeah. So this is vague. So the last statement, whatever I said, it's a sort of a vague statement. Okay, we can make it little more precise. Okay. So for example, if I take this function f of x is equal to 1 by x, okay, so this function, so 0, whether 0 is in the domain of the function or not?
Sir.
No, sir.
No, sir.
So 0, basically 0 is not in the domain of the function. Okay, 0 is not in the domain of function, but still I can talk about the limit of the function at 0. Okay. Still I can talk about the limit of the function at 0, which is basically doesn't exist. So it depends. Like even if this a is not in your domain of the function, still you can talk about the limit of that function at this point A. Okay. So the main idea, to find a limit is basically first you compute the left hand limit, then you compute the right hand limit. Then in the next thing, you need to check whether both the limits are equal or not. If the left hand limit and right hand limit they're equal, then you say that limit of this function at that point exists. Okay. Okay. So you have a function which is x. Okay. The value of the function is x if x is less than 2, right? If x is less than 2, then the value of the function is x, and if x is greater than 2, the value of the function is 5, right? Then we can easily draw the graph of this function, right? So what we know if x is greater than or equal to 2, so here x equal to 2. So if x is greater than or equal to 2, then the value of the function is x. So
less than equal to
Less than.
sorry,
Less
yeah,
than.
less than or equal to.
It is 5 only.
Right? And if x is greater than 2, it's 5.
Constant.
Yes. So this is not included. It will be something like this. Now we need to compute. So we need to know. So more or less, we need to know whether the limit of the function at x equal to 2 exists or not. So for that, what we need to do, we need to find the left hand limit, right?
Yes.
Left hand limit, right hand limit. If they matches, then we can say that the limit of the function at x equal to 2 exists. Okay, and then we can tell what is the limit of that function. Okay, so first tell me what will be the left hand limit of the function? 2, right? So as you can see, when you are coming to this point 2, right, from the left hand side, right, from the left hand side, when you are coming to this function, when you are coming to 2, then as you can see, the value of the function, this is the value of the function, it's basically approaching towards 2. Okay, this is basically approaching towards 2. That means the left hand limit is 2, right? Then what about the right hand limit?
5.
5, correct. So again when you are coming to 2 from the right hand side, okay, when you are coming to 2 from the right hand side, so when you are coming to 2 from the right hand side, then the value of the function
5
will come closer, and basically it's 5 throughout all the points, it's 5. Okay. So it's basically 5. Okay, so then we have a problem here, right? Because my left hand limit is 2 and my right hand limit is 5. So these are not equal, right? So then I say that limit of this function at x equal to 2 doesn't exist. Okay, so that means the first option is incorrect, right?
Yes, sir.
And the second option says the right hand limit exists at x equal to 2, which is correct, right?
Yes, sir.
Yes, sir.
Because we have a value for our right hand limit, which is 5. So if option 2 is correct, and the left hand limit,
But
Correct.
right. Yes, sir. Yes, sir.
So what about option 3?
Yes, sir. It is correct.
Correct.
Correct, sir.
Correct, sir.
And since option 3 is correct, option 4 cannot be correct.
Sir, I have a question here. Why can't we write f of x is equal to x for left hand limit?
No, sorry, can you repeat?
Can't we write limit of f of x is equal to x for left hand limit? Why we have written means because we are calculating it at 2. That's why we have written f of x is equal to 2 left hand limit.
No, this left hand limit at 2 I'm talking. So the thing is I'm computing the left hand limit of this function at x equal to 2, right? So what we need to do for that? What we have to do? to find the left hand limit.
Approach 2 from the left hand side.
So first, if you approach this 2 from the left hand side, right?
Mhm.
So when you are coming to 2 from the left hand side, you have to see where this value of this function is approaching, right? Suppose
approaching where it is
yes,
approaching.
yes, correct. So if you take this sequence 2 1 by n, okay, so this sequence is coming to 2, right?
Right.
From left hand side, correct? Now you see what will be the value of this one. This is also 2 minus 1 by n, right?
Yes.
This is also approaching towards 2, right? So when you are coming to 2 from the left hand side, you have to check how the value of the function behaves. Okay, so you have to check how the value of the function behaves. So you can see that this value of the function is also going towards 2, right?
Yes.
Yes, so that's why this left hand limit is 2.
Sir, excuse me, sir. Sir, approaching towards 2 means we no need to go to exactly at the 2, right?
No, you see, approaching, see the sequence, when I said this sequence 1 by n, okay, approaches to 0, that doesn't mean that 1 by n, 1 by this sequence has to reach 0. This sequence is never 0, right?
Right, sir.
But still we are saying that 1 by n approaches to 0.
Okay. No, sir, I'm talking about the function. This one.
Same for the function. Okay, same for the function.
Okay, sir.
Sir, I didn't understand option 2, sir. Right limit exists at x is equal to 2.
What is the right limit of this function at x equal to 2?
X is equal to 2 plus x tends to 2 plus it is 5.
This is the right hand limit, right? We are using this now. So then we have a value for the right hand limit, right?
Yeah, but at 2 it is not there, I think.
No, this is the right hand limit, right? At x equal to 2. This is the right hand limit.
Okay.
This is precisely the right hand limit, right? And we have a value for right hand limit, which is 5, right?
Okay.
That means the right hand limit exists at x equal to 2.
Okay. Got it.
Yes. Okay, so okay, let me take this this example. So next we need to find this limit of the function at the given points. Okay, so what about option 1? How I can compute the limit of this function?
So sir, no sir. Sir, firstly put x equal to minus t and convert the whole question into t, and after that calculate.
Okay, so before that let me tell what is the way, what is the best, at least for me, what is the best way to solve this question. Okay, something is given.
Firstly convert into new variable. Yes.
Let me wait some. So f of x and g of x is a polynomial, right? F of x and g of x is polynomial. Okay. So first thing what you need to do, you need to check whether g of a is 0 or not. Okay. So if g of a is not 0, okay, if g of a is not 0, then what you need to do, this limit, you can blindly say that this limit is f of a by g. Okay.
G of a.
Yeah, correct. And the problem is, if the problem occurs when so this will happen if g of a is not 0. Then if g of a is 0, then what you need to do, you need to factorize both f of x
and g of x.
F of x and g of x. And what you need to do, you need to cancel the common factors. Okay, so you need to cancel the common factors, and then after that you start calculating the limit. Okay, so okay, so the thing is,
option 1 is correct.
How? Can you tell me?
Sir, x plus 1 upper one factorization is x plus 1 into x minus 7.
X minus 7.
And denominator is x plus 1 and x into x plus 2. So x plus 1 will be eliminated.
So the
and we will put
so
limit x is equal to minus 1.
It is 0, both denominator and numerator.
No, sir. So as you can see in the first option, okay.
So minus 1 minus 7 is minus 8.
Okay, let me do it. Okay, so as you can see, when you start checking the first option, so the first thing what you need to do, you need to check whether this function which is in the denominator, whether this is 0 at x equal to minus 1 or not. Okay.
So it is 0.
0, right? Because minus 1 plus 3.
Yeah, it is 0.
Plus, okay, I guess this is, sorry, this is 1. This is
so,
minus 3 plus
1
2.
minus 3 plus 2. Yeah.
Okay. So then what we need to do, we need to factorize both the function in the denominator and numerator. Okay. And if you factorize the function in the denominator, what I can write, x square minus 6x minus 7 is nothing but x minus
x plus 1 into x minus 7.
Correct. X minus 1 into x plus 7. And what about the
no, sir.
denominator?
Hello. So x plus 1 into x minus 7.
Yes, sir. X minus 7 and x plus 1.
Okay, fine. Yeah, sorry.
Opposite.
Then sir, denominator is x plus 2.
X plus 1 and x
Plus 2, x plus 1. So x plus 1 will get cancelled out.
X plus 2 into x plus 1, right?
Yeah.
So now what you do, you cancel these two things. Okay, now you are left with x minus 7 by x plus 2. Okay, now you apply the limit. Okay, now if you apply the limit, okay, so limit x towards minus 1 is nothing but limit of this one. Okay, now you apply the limit, what you will get, now you can see that the function which is in the denominator is not 0 at x equal to minus 1. So this is precisely
minus 8 by 1.
Minus 8 by 1, which is minus 8. Okay. And what about
Why
option?
do we need to factorize, sir? Why not we apply the value directly, sir?
No, this is 0, right?
Yeah.
Denominator is getting 0 if we put directly x.
So if you directly put 0, okay, so then what you will get something divided by 0, right?
It is 0 upon 0.
Sir,
0 by 0
by 0 form.
Yeah, sorry.
Sir, 0 by 0
because
form.
they have both the polynomial have
0.
Yeah, 0 at x equal to minus 1. So you will get basically 0 by 0. So from that actually you cannot conclude anything. Okay.
So we can
avoid
use L'Hopital rule, sir. Derivative
okay.
of
that will come later. Okay. Now now I'm talking about limit. That will come later. Certainly you can apply L'Hopital rule here. Okay. Undoubtedly you can apply L'Hopital rule and you can get the answer. Basically you need to differentiate both the denominator and numerator, and then you can apply the limit. Okay. More or less I'm doing the same thing. Okay. Slightly different. So what about option 2?
Sir, option 2 is minus 7 upon 2. So that is not correct.
Because the problem is okay, here the main thing is this function is the function in the denominator is not 0 at
not
0.
Getting 0 by 0.
Yes, because see, if you take this g of 0 is not 0, right? So what I can do, I can simply take this as f of 0 by g of 0, which is 7 minus
7 divided by
2. Okay, so option 1 is correct and option 2 is incorrect. Okay. And what about option 3?
Correct.
You can simply apply it because
yes, sir,
there is no
yeah. So nothing tricky here. You simply apply. Okay. And what about option 3?
Incorrect.
So it is
incorrect.
It is equal
it
to
is
0.
incorrect. It is 0.
Again for option 4, you have to do whatever we have done for option 1, right?
Yes.
Yes.
Because this is 0. Okay, so we don't have to factor this polynomial because it's already in the simplest form, but we need to factor the polynomial which is given in the numerator, right?
So it is x minus 3 ka whole square.
Yeah, so this is x minus 3 whole square by x minus 3, and we are getting x minus 3, which is now if you take x tends to 3, then this is 0. Yes. Okay. Okay, so okay, so the next thing is sandwich principle. Okay, so how one should apply the sandwich principle. So you have already seen one example, like for the sequences, you have already seen one example, like how you are applying sandwich principle here. Okay, so more or less the idea is same, but you can apply the same idea in multiple places. Okay, so suppose you have a function which is f of x, right? You have a function which is f of x, and you know the limit of the function at f of x is L. Okay, so you have a function and you know the limit of the function at x x equal to a is L, and similarly you have another function g of x and limit of this function at x equal to a, which is L, and you have one more function which is hx, and hx is basically sandwiched in between
fx and
g of x and f of x. So since we know the limit of this function at x equal to a, and since we know limit of this function at x equal to a, okay, then we can simply, if you take, and they are same, so now if you take the limit, then the limit is will also satisfy this inequality, right? The limit of this limit will also satisfy this inequality, but this is L and this is L, right? That means the limit of h of x is also L. So
can you please make some graph of these three functions, fx and gx?
Yes, sir. Graph.
So the thing is, okay, so the problem with this graph is it's more or less difficult to draw, because at eventually, okay, so at eventually their graph at x equal to a, you can't differentiate the graph. Okay, they are so close. Okay, so they're so close that it's more or less for you to differentiate the function. Let me try to draw it. Okay, so something like that. Let me take this function. This is my function. Okay, this is x equal to a, and this function is my first function. This is g of x. Okay, and this one is my h of x. Okay, okay, this is my h of x. Okay, and sorry, this is my f of x. Now if I have a graph like this, okay, so then basically you can see that f of x is basically this h of x, the graph of h of x is basically in between the graph of g of x. The graph of g of x is basically above the graph of h of x, and graph of g of x is graph of f of x is below of graph of h of x. So when you will come towards x equal to a, let's say this is a, okay, so then the limit of both the function will coincide. All the function will coincide.
Yes, sir. Okay. Thank you, sir.
Yes.
Yeah, superb, sir.
Okay. Okay, so okay, since now you know sandwich principle, how you can apply this. Okay, that now it's your duty to compute the limit of the function using sandwich principle, because I have already done something similar for limit.
It will be 0.
It will be 0, sir.
Yeah, so it's certainly it's 0, but how
Because cos 1 by x lies in between -1 to 1.
correct. So now you have cos 1 by x, and you know this cos function is basically bounded lies
Sir,
in
it is an oscillatory function.
-1 to 1.
Yeah, certainly it's oscillatory. I agree that it's oscillatory, but certainly it cannot go beyond it cannot go
Yes.
below of -1 and cannot go above of
Above
1.
1. Yes,
Yeah.
yes.
I know certainly it's oscillatory, but the value cannot be go beyond of this interval. Okay.
Excuse me, sir. Can you
Yes.
repeat before 2 minutes? I lost my connection. So.
You can watch it in YouTube. Okay.
Okay, sir.
Yeah. So the thing is now this cos 1 by x is basically in between 1 and -1. Okay, but what I want limit of some different one, like some different function, that is cos x multiply cos 1 by x multiply with x square, right? So then what I need to do, I have to multiply x square. Okay, if I multiply x square, what I will get? X square here, x square cos
1 by x less or equal x square.
Now I can easily compute the limit of this function at x equal to 0, right? And similarly, I can easily compute the limit of this function at x equal to 0, which is precisely 0. This limit is 0.
Yes.
This limit is 0. That's why this limit is also 0. Okay. So sometimes, yeah, you can easily compute the limit of some complicated function using sandwich principle. Okay.
Can you please repeat this inequality minus x square?
So cos x, you are talking about this one, right? You are talking about this one.
Yes, sir. Yes,
Yeah,
sir.
the value of cos x. Okay, value of cos x is basically is always in between -1 to 1, right?
Yeah, yes, sir.
So that is what I have written. So cos basically, see, 1 by x is again, it will give you some number. Okay, so let's say cos 1 by x, instead of writing cos 1 by x, okay, 1 by x is something t, right? And cos t is always less than 1, and it's always greater than equal to -1. So I have written the same thing. Okay.
No, sir, minus x square and x square. So how did you get these two?
No, x. Okay, so this one is clear. This inequality is clear.
Yes, sir.
This inequality is clear, right? And next thing is x square. It's positive, right?
Yes.
It's always positive. So if I multiply with something, then it will not change the direction of this inequality, right?
Yes.
Always it will preserve the direction of
yes.
all the inequality, right? So now what what I'm doing, I'm multiplying x square, right, with -1, with cos 1 by x, and with 1. That's why I'm getting. So if I multiply x square, then after that I will get the same inequality. Not same inequality, but the order of the inequality will be same, right?
So, sir, I have a small doubt. Like in case of every time when there is a trigonometric function is associated with such variables which are in terms of like upon something. So at all that time, it is advisable to apply first the sandwich theorem just for sake of saving time, like.
Yes, certainly. Like, because see, the thing is, okay, so most, like, at least in this course, most of the cases you can apply. But
especially during for examination.
Yeah, certainly you cannot do it all the time, but yeah, but you can apply sandwich theorem.
Okay.
Sir, here how sandwich theorem is being applied? I can't understand what is hx and gx.
This is h of x.
No, fx and gx. Are we separating fx equal to x squared?
This is g of x. This is f of x. correct? Hello.
Yes, sir.
Okay.
Sir, please proceed further.
Yes. Okay, so yeah.
We directly put the value of x.
No, you can't. You can't, because cos 1 by 0 doesn't exist. Okay, so you can't put x equal to 0, because if you put x equal to 0, then what you will get? 0 into cos 1 by 0.
1 by 0. That
this doesn't exist. Okay, if something doesn't exist, you cannot multiply that thing with 0. Okay, you can multiply 0 with some number. Okay, you can't multiply 0. If 0, you cannot multiply 0 with maybe say maths 1. Okay, this is not a number. Okay,
yes.
You can multiply 0 with a number. Okay, so this doesn't exist. This is not a number. Okay, so it has no meaning.
Okay, sir. Thank you, sir.
Okay, so let's go to continuity. Okay, so since you know the definition of limit of a function, so continuity is more or less the same thing. So the extra thing what you need to do here for continuity, once
find the value of that.
Sorry.
Function at that point
You have
equal
to
to
find
limit.
the value of that.
And the value of the function at that point is equal to the limit. Means RHL is equal to LHL equal to.
You are talking about the limit of this function, or sorry, I didn't.
No, sir. No, sir. For continuity.
Continuity.
Yeah, continuity. I'm coming. Okay, so yeah, so whatever you have said is correct. So the extra thing what you need to check after checking the limit, you need to check whether the limit is same as the value of the function at that point. Okay, so when you can see, now the checking, so when you are checking the continuity of a function, what you need to do, first thing is you need to check whether the limit of the function at that point exists or not. Okay, so the first thing you need to check whether the limit of that function at that point exists or not. If f of a doesn't exist, sorry, limit limit of this function doesn't exist, then directly you can say that f is not continuous. Okay.
So whether exist and defined same when we say exist or defined, whether both?
Yes. Limit, no, limit exist and limit defined more or less the same thing, but limit exist and function is defined, that these are two different. Okay. So so if first thing, when a function is given and you want to know whether this function is continuous at a point or not, okay, so let me tell you, I have missed one thing. So you should not check the limit first. Okay, this is even slightly, this is the next process. Okay, you should not check that whether limit of the function exists or not. First you check whether this function is exist or not, the value of the function at that point exist or not. If the value of the function at that point doesn't exist, okay, then you say that if the value of the function doesn't exist, then you can say that this function is not continuous at that point. Okay, if it doesn't exist, for example, if I take this function, okay, 1 by x, and if I ask whether this function is continuous at 0 or not, then what will be your answer?
No,
it's not continuous, because so I want to know whether this function is continuous at x equal to 0 or not. Okay, so what is my first step? I go and I check what is f of 0, and I get f of 0 doesn't exist. Okay, then I can say that, okay, I can say that this function is not continuous at 0. Okay, I don't have to go to the further step, and I don't have to check anything else. I check f of 0 doesn't exist, and then it's not continuous. Okay, so now suppose f of a exists. Okay, so suppose f of a exists. Okay, so suppose this is, so f of a exists. So next thing what you need to do, you need to check the limit of the function. The next thing is, what is the limit of the function? Okay, if the limit of this function doesn't exist, then I don't have to go to the next step. So now I can, from here itself, I can say that f is not continuous. Okay, so for example, if I go back and check this one, question number 4, right? Am I audible?
Yes,
yes, sir.
Okay,
Yes,
I'm okay. Sorry, I'm getting some noise in between. So if you see here, so suppose I want to check the limit continuity of this function f of x at x equal to 2.
Not continuous.
Okay, let me. Okay, you are correct, but let me go through go through step by step. Okay, don't jump into the conclusion. Okay, so at x equal to 2, the function is defined, right?
Yeah, yes, sir.
What is the value?
5
X.
2.
Oh, sorry.
2.
Okay, so the first step is fine. Okay.
Sir, one small request. Sir. In case of x, can you please write like means x? It looks like k, small k. Just a small request. Yes.
Oh, that's understood.
Sometimes we are confusing where it is that variable is.
Now this is fine.
Yes, sir. Yes, sir.
Okay. Okay. You can keep reminding me because okay, I'll try to check. So, so this is fine, right? So the value of the function at 2 is 2. So I'm done with the first step. The next step is I have to check the limit, but we have already computed the limit. Okay, so the limit of this function doesn't exist at that point. Okay, so then I don't have to go any further. I can directly say that this function, whatever I have defined here, this is not continuous at x equal to 2. Okay, so this function is not continuous at x equal to 2 because this function don't have limit at x equal to 2. Okay, so suppose
whether the function is defined at, can we say whether function is defined at 2?
But that I have already said, right? This function is defined. That is the first thing you need to check, and we have already checked that this function is defined at 2, and the value of the function at 2 is 2. Okay.
This function at x equal to 1, can we visually say that it is continuous?
Yeah, you can
visually the graph.
Yeah, I'll come to that. Okay, I'll come to that. Yeah, you can easily see that at x equal to 1, this function is continuous, because if you see, okay, then again you have to
from left and right we can visually say that.
Yeah, visually you can say that this is continuous. Okay. So the next thing what you need to do, so suppose the limit of the function exists. Okay, then the third step is, so first step, if the first thing doesn't hold, then from there you say that this function is not continuous. If the second step doesn't hold, then you can, from there itself you can check that, say that the function is not continuous. Suppose both the condition hold. Okay, so the next thing what you need to check, if the limit of this function is same as the value of the function. Okay, if the limit of the function at a is same as the value of the function, then you can say that if all these three conditions holds, then you say that f is continuous.
In what circumstances the third condition wouldn't be there?
So the thing is, so it's depend, like so you have, like, you can define your function according to u, right? You can define a function according to u, right?
The example which we were referring to does not.
No. This is yeah, I'll come to that. So for example, let me take one example. So suppose so
this was just for a theoretical aspect, right?
Yes,
sir?
yes.
Okay, yeah.
So the thing is so my point is, first you try to check the first thing. Okay, it doesn't hold.
Yes, sir.
Simply you don't have to check the second and third thing. Okay, if the first thing doesn't hold, okay, stop your calculation there. Okay, if it's not continuous, then you come, if suppose first condition holds, then you come to the second condition. If second condition doesn't hold, then don't go to the third. Just
one. Yeah. Okay.
stop there and say that f is not continuous. Then you come to the third. If third doesn't hold, then also you can say that f is not continuous. If third condition holds, then you can say that f is continuous. Okay, so let me tell when condition, let me take an example where the condition 1 holds, condition 2 holds, but the condition 3 doesn't hold. Okay, so let me take for example, take a function f of x is let's say x, right? If x is less than 0, correct, it is x square. If x is greater than 0, and so the thing is, now I have a control, like, because I basically I'm defining this function. So what I do, at x equal to 0, I'll define this as 2, right? So this is my function. Okay, let me draw the graph of the function. Okay, so at x equal to 0, so this, if x is less than 0, correct? If x is less than 0, the value of the function is x. So this is the graph, and this 0 point is not included. Okay, let me tell you. So this is not included. Okay, because the value of the function is x. If x is less than, you have strictly less than sign is there. Okay, and if x is x square, sorry, if x is greater than 0, the value of the function is x square. Okay, for example, it will be something like this. Okay, and at x equal to 0, the value of the function is 2. Okay, this is f of 0. Now what I need to do, and first so my main aim is to check whether this function is continuous at x equal to 0 or not. Okay, that is my aim. So the first thing what I need to do, what is my first?
Defined or not?
Yes.
First, you have to check whether it is defined or not.
Yeah. So whether this function is defined at x equal to 0?
Yes, sir. It is
Yes.
defined.
So f of 0 is 2. So this is fine. So next thing is, what is the left hand limit? I need to check the limit of the function. What is the left hand limit?
0.
Left hand limit is 0. Is it clear why this left hand limit is 0?
Yes, sir.
Yes, sir.
And what about the right hand limit?
That is also 0. Sir, actually I joined late.
There is also
So
0.
can you just brush up in 1 minute? Left and right hand limit.
No, sorry. Like it's this recording is available in YouTube. You can.
Just 1 minute, sir. In just 1 minute.
No, sorry. So this is also 0, right?
Yes, sir.
This left hand limit is 0, because if you see this graph, when you are coming to 0 from the right hand side, the value of the function is approaching towards 0. That's why this right hand limit is 0. Okay.
Yes, sir.
And when you are coming to 0 from the left hand side, at the same time also this value of the function is also going towards 0. Now, so the both left hand limit exist and they are same, right?
Yes, sir.
So the limit of the function at x equal to 0 exists, right?
Yes.
So now okay, I have already checked first step, and the second step is also fine. Okay, so next go to the third step. Okay, whether limit of this function f of x, whether it is equal to f of 0.
No, sir. No, sir. No, sir.
No, right?
No, sir.
Because actually, okay, intentionally I have changed this value. Okay, so I have changed this value to 2. Okay, so that means these two things, they are not same. Okay, that means f is not continuous.
Thank you, sir. Good
Yes.
example.
So how do you say that? What is the f of x here? Whether it's x or x
F of
square?
0 is 2.
So instead of that, if I change this to 7, then also it is not continuous. Okay, this is continuous if and only this is 0.
0.
Yes.
So if I change this function to in this form, then this is continuous. This is continuous.
Sir, can we say that if there is a jump in the graph, the function will not be continuous?
Correct. That is basically, so when there will be a jump, certainly this is not continuous. Yeah.
And if there is a sharp corner, then it is not.
But okay, when you have a jump, so in that case the limit also may not exist. Okay, this situation can occur and can occur also. You don't know whether it will occur. Okay, if you have a jump. Okay, so for example, if I take this one, let's say this graph, some graph like this. Okay, and another graph like this. Okay, so here if you see, you have a jump, right? This is the graph of a function. Okay, you have a jump here, right? So if you see, actually here the left hand limit, you will get this number. Okay, and the right hand limit
will be
you will get this number. Okay, so here right hand limit and left hand limit, they are different. Okay, so in that case, from the step 2 itself, you can say that the limit doesn't exist. That's why the function is not continuous. Okay.
So like greatest integer.
Sir,
correct.
Sir,
Yes.
is it necessary for limits to exist so as to become continuous?
Yeah. So from the definition, it's
Yes,
clear, right?
it is by definition. Yes.
No, vice versa. Means if we are given continuous function, can we say that their limits are equal?
Yes.
Yeah, because by definition, if the limit doesn't exist, then the function is not continuous, right? That is correct. Yeah. The way we have defined this continuity, if limit doesn't exist, then f is not continuous. Do you agree?
Yes, sir. But if limit exists,
I'll come to that.
Possible?
I'll come to that. So when you are saying that f is continuous, so you are saying f is continuous, right?
Yes, sir.
And you want to know whether the limit exists or not.
Yes.
Okay, yes.
But if you say that the limit doesn't exist, okay, then f can't be continuous, right?
Yeah, that is obvious.
Yeah, so that is what, right? You are basically asking the converse, right? If I said if limit doesn't exist, then f is not continuous. Okay. So
No, I am telling that limit exists. Both the left hand and right hand limit are equal. But it is not necessary to be continuous.
Yeah, this is the example. Yeah. Whatever example I have given here, okay. Whatever I have example given here, so here left hand limit and right hand limit exist, right? And they are equal, but still the function is not continuous, right?
Yes, sir, because zero can't be anything.
Yes, okay, let me take this. Previously it was, I guess, 2. Okay, so this function is not continuous, right? Is it clear?
Sir.
Like,
Yes, sir, it's clear.
So again, continuity implies limit exists.
Limit will exist.
Okay, and limit exist doesn't imply continuity. This is the perfect example, whatever we have discussed now. Okay, here limit of this function exists at x equal to 0, but this is not continuous. Okay, that's why continuity. Okay, remember continuity implies limit exists, but limit exists doesn't imply that function is continuous. Okay.
Yes,
When
sir.
you take it for the last one, f of x, what you have taken, whether it is x or x square.
Sorry,
when we say that f of x is not equal to f of x is not equal to f of 0. How do we say that the f of x, whether it is x or x square?
No, f of x, we need to compute f of 0, right? So in the last step, what we need to do? We need to check whether this limit is equals to f of 0 or not, right?
Yeah.
So by definition, f of 0 is 2 here.
Okay.
So limit is 0, but f of 0 is 2, and they are not equal, right?
Okay.
Since they are not equal, so this function cannot be continuous.
Got it. Thanks.
Yes.
Thank you.
Yeah. So
what does the last line mean in previous slide? Yes, sir.
Okay. So this is another way of checking continuity. Okay. So the thing is, okay, slightly tricky. That's why I didn't explain this. So the thing is, what you need to do, you need to see another way. You can say that the function is continuous at x equal to 2. X equal to a. If for all sequence xn, which are converging to a, if it imply that this sequence converges to f of a, then you can say that this sequence, this function is continuous at x equal to a. Okay. So let me just slightly tell you. Okay, please mute yourself. So let me tell you. So this function, we have already, I have explained you, like this function is not continuous at x equal to 2, right?
Yes, sir.
So okay, please mute yourself. Okay, let me. Yeah. So the problem is, okay, in the definition, if you see here, I have said, I've written what. So if for all sequence xn which are convergence to a, if it implies that f of xn also converges to f of a, then only I can say that f of f is continuous at a. That means if I have at least one sequence, xn which converges to a, but f of xn doesn't converge to f of a, then I can say that this function is not continuous at a. So for example, here if you see, if I take a sequence which converges to 2, let's say this sequence an. So let's say my sequence xn is 2 plus 1 by n, right? This sequence converges to 2, correct or not?
Yes, sir.
Yes.
Now if I take take this new sequence f of xn, what is f of xn?
2 plus 1 by n.
F of 2 plus 1 by n. What is this? F of 2 plus 1 by n. It's always 5, right?
Yeah, greater than 2. Okay.
Yeah, because 2 plus 1 by n, it's always greater than 2.
Yes.
So x is greater than 2. That means f of 2 plus 1 by n is 5. That means this sequence, this new sequence, f of xn, this doesn't converge to f of a, which is 2, right? That's why this function is not continuous at x equal to 2. So okay, so
Sir, sir, how is that f of 2 plus 1 by n equal to 5?
Okay, so no, okay, so if you want, I can explain what is why f of 2 plus 1 by n is 5. Okay, so what is x here? What is x here? F of x, in f of x, what is x here? This is x,
2 plus
right?
1 by n. Yes.
So x is 2 plus 1 by n, right?
Yes, sir.
So 2 plus, whether 2 plus 1 by n is greater than 2 or not?
Yes, it is greater than 2.
So if x is greater than 2, what is the value of f here? By the definition of f?
Oh, by this definition. Okay,
Yes,
sorry, sir.
yes, yeah. Okay, so okay, again, like as I said, this is slightly tricky and you need to apply this carefully.
So while we apply that value, sir, we don't take that 1 by n is tends to 0, tends to
No,
infinity.
no,
We
no,
don't
no.
apply that rules and all when we apply directly f of s.
Yeah. So again,
Okay.
again, so if you have not studied that thing till now, then I'll suggest ignore it.
Okay, sir.
Yeah. Because as far as I know, I guess Saran sir mentioned this one in the lecture. Okay. Okay, so what about this function? Whether this
Sir,
function
can we take the continuity as a literal meaning that particular graph is not continuous?
that is yeah. Basically, we are taking the literal meaning. Yes.
Literal meaning, right?
Yes.
Okay,
If you can draw something without lifting your pen, then this is continuous.
This is continuous.
Yes. Okay. What about
Not continuous.
What about why this is not continuous? Any idea?
Sir, it is continuous. Sir, it is continuous.
But sir, at 0 left hand limit and right hand limit won't be equal, na?
Okay, okay.
But at 0 it will be equal.
We'll check. Okay, let's see whether this function is continuous. Okay, let's see. Okay, so the first step, what you should do,
It is defined.
F of
X
x
equal
is
to
defined.
x equal to 0. F of 0 is defined, right? Which is 0.
Yes, sir.
So this is defined. So the next thing is you need to compute the limit of this function, right?
Yes.
At x equal to 0. So if x is less than 0,
yeah,
what is the value of
Mod
x?
X minus x.
Minus x, right? If x is greater than 0, then mod of x is
Plus x.
is plus x. Okay, this is basically x, because I have already mentioned that x is greater than 0. So okay, so my next task is compute the limit of this function. Okay, limit of this function at x equal to 0. So for that I have to first I have to take the left hand limit, 0 minus. Okay, so 0 minus x minus x. Okay, please mute yourself.
X.
Okay, yeah.
So fx will be x.
So this is x square
X
minus mod x, right? Correct. So here x tends to 0 negative. That means I am coming to 0 from the negative side, right? Is it clear whatever I am saying?
Yes, sir.
So I am coming to this 0 from the negatives, from the negative side, right? That means here the value of x is negative. So
Yes.
that means mod of x is what?
Minus x.
Minus x. Okay, which is minus x.
Minus x.
So
Yes,
what is limit of minus x? As x limit x tends to 0,
it will be 0.
it is 0. Okay, so this is the left hand limit. Yes.
Yeah, when it is mod of x, it is mod, right? How come we can tell it is minus x there?
Yes, sir, absolute value, right?
No. So the thing is, that is what I have defined here, right? Do you agree whatever I have defined here? Do you agree with this?
But sir, how did you define this?
Yes.
This is the definition of mod of x.
Yes,
So
this
I-
is mod definition.
Yes, mod
Yeah.
definition of model.
Yeah.
So I have maybe I have said it a lot of times in the previous session. So this is how
Yeah, this
you
is fundamental definition.
this is how you define mod of x. Okay, mod of x has a definition.
Okay, you defined the mod function there. Okay.
Yeah, so I have defined mod of x. So when I'm computing this right hand limit, sorry, left hand limit, 0 minus, right? I'm coming to 0. Basically, I'm coming to 0 from the negative side, right? So that means here the value of x is negative, right? So x square by mod of x. So here, so when I'm coming to 0 from the negative direction of 0, here x is negative. So by definition, if x is negative, then the value of the mod x is minus x, right? Is it clear why actually I can write this as minus x?
Yes, sir.
Yes, sir.
This is limit x tends to 0 minus
X.
minus x. What is this limit?
0.
0. Similarly, you can compute the right hand limit now.
It is also 0.
0.
That is also 0.
By
It's
x
continuous.
equal to 0.
So now both left hand limit and right hand limit exist, right?
Yes, sir.
Yes, sir.
Yes, sir.
And they are equal.
Yes, sir.
So that means limit exists.
Yes.
Yes, sir.
And the next step,
Continuous
next
also.
step is you can see that the limit is basically same as f of 0.
Sir, and
Yes,
it is,
then continuous.
it is continuous.
Correct.
It is continuous.
Yes. Okay, so okay, so I guess okay, let me do it quickly. So any idea why? Can you tell me why this is? Can you tell me the answer of this question? Because I have taken
Just a
this
second,
one
sir, we are
from the
calculating.
activity.
1 minute, sir.
Not. It's not. Okay.
It is not continuous. It is not continuous, sir.
Yes. Okay,
Yes,
so
sir, it is not continuous.
okay, option 1 is correct. This is not because why this is not continuous? Because
Because
Left limit 1, right limit 0, sir.
correct. So basically, since this basically the limit of this function at x equal to 0 doesn't exist. Okay.
Yes.
So the limit of this function at x equal to 0 doesn't exist. So that's why this function is not continuous at x equal to 0. Okay, you try this. And what about option 3?
Sir, actually, we got this question in quiz 2 also. Means one of the option. So how to check get the bounded value?
Yeah, that is what I'm asking to you now.
It's not bounded.
It's not bounded.
It is bounded.
Yes. If it is not bounded, then why? If it is bounded, then why?
Oh, this is just a guess. I thought, if it is defined between some ranges, it is bounded. But I do not know the definitions.
Sir, it is bounded between 0 and 1. Sir.
Infinity, minus infinity, and also discontinuous points. And
wherever does not.
Okay, let me do
minus
it.
infinity or
Okay,
infinity.
let me do. Okay, so e power x, e power 1 by x, it is always greater than or equal to 0. Correct?
yes, sir.
Yes, sir.
1 plus e power 1 by x is always greater than 1.
Yes, sir.
Yes, sir.
If I take the reciprocal, then what I will get?
Less than or equal to
1 plus e power 1 by x is
Less than or equal to 1.
1, and it's also greater than or equal to 0, right? Because
Not equal to 1, sir.
okay, I'm giving a bound. I'm not saying that it can achieve 1. Okay, I'm saying that all the values, see, I can write this one, right? Sine x is less than or equal to 2. Can I write this or not?
Yes, sir.
Because sine x is less than 1, so certainly it will be less than 2. Okay.
Yeah.
So it doesn't matter whether this function will achieve 1 or not, because I'm writing it's less than equal to. I'm not saying that it is equal to 1. You have to differentiate these two things. Okay, less than equal to is basically it's including both the cases. It can be either less than or it can be equal to. Okay.
Yes, sir.
Is it clear now? Okay. So now,
So can you please explain again reciprocal thing?
Yeah. So this part is clear, right?
Yes, sir. Yes, sir. It is clear.
Then see, if x is greater than if m is greater than 1, okay, that means 1 by m is less than 1, right?
Oh. Okay. So actually here we are getting the inverting each and every term, right?
Okay. So again,
M is
please please mute yourself. When you are talking with someone else, please mute yourself. I can't repeat it again and again. Also, okay, next time I'll remove you from the session. Okay. You can't be so careless. Okay, so so the thing is, as you can see, so what I was saying, if a number is greater than 1, okay, if I take the reciprocal, then it has to be less than 1, right?
Yes. So we are inverting each and every term that in that case, right?
Correct.
Means
correct,
m
correct.
is 1 by m greater than is converted to less than
more generally, whatever you are saying, if m is less than n, then 1 by n is less than 1 by n. Correct?
Correct.
So
zero
here
is not included in the range.
So here, if you see, right, 1 plus 1 by e power x is always greater than 1. Right?
Yes, sir.
Yes, sir.
So now
Yes,
if I invert it, so what I will get? I will get 1 by 1 plus e power x, which is less than 1 by 1, which is 1. Right? And I know 1 plus e power x is greater than 0. Right?
Yes.
It's always greater than equal to 0. That means this whole term will also be always greater than equal to 0.
Yes, sir.
So that means the value of this function is basically always in between 0 and 1. Okay. That means it's a bounded function. Is it clear?
And it can't be 0.
Yes, sir.
It can't be 0. Again, someone already asked the same question, that it can't be 1. Yeah, it can't be 1. That I'm not saying that it will take the value 0. Okay, that's why again I'm saying I'm not writing this as 0. Okay, so if I write this as 0, then only you can say that okay, this is incorrect because this can't take the value 0. But instead of that, I'm writing less than equal to. That means this is less than or equal to. Okay. Okay, fine.
Sir, your option 2 should be correct, no?
Why option 1 is
Option
wrong,
one.
sir?
No, this as I said, this is already in activity. You try to do it. I will not solve this question. You try to do it. It's
Option 1 and option 3 are correct.
Option 1 and option 3 are correct. You try to do it. Okay, it's there in your activity questions.
I'm getting option 2, but it is not continuous. So that's right.
It's not continuous.
Option
Again,
2 is wrong.
let me tell you the correct answer. Option 1 is correct. Option 2 is incorrect. Option 3 is correct. Option 4 is incorrect. Now you try to do it. Okay.
So I have a question.
Mm-hmm.
So when we say bounded, it means that the range is within certain value?
Certain interval. You can say certain bounded interval. Okay. So for here, if you see, the range is basically in between 0 to 1. Okay. So that's why it's basically the range of the function is in between a bounded interval. Okay. So that's why this is a bounded function. For example, if you take sin x, okay. So this is a bounded function. Yes, cos
between
x.
-1 and 1.
Yeah, it's the range is basically in between -1 to 1. Similarly, cos x is a bounded function, but tan x, it's not a bounded function. Okay, you can't restrict the range of tan x in between some bounded interval. Okay, so that's why tan x is not bounded function. Okay, let me tell you, what about this function 1 by 1 plus x square? Is it a bounded function?
Yes, sir, bounded.
This is a bounded function because it's more or less you can restrict the range of this function in a bounded interval, because using the same trick. Okay, whatever trick I have used here, you need to use the same trick.
Yes, sir. X square is greater or equal
than
to
0, then 1 plus x square is greater than equal to 1. Then you reverse it.
Yes,
then
sir,
you take the reciprocal. Okay. You will more or less you will get the same range. Okay, not range. Okay, same bound, you can see.
Yes, sir.
Sir, but in option 3, it has given us.
I don't know about option 3. I don't know about option 3.
Hello, sir.
Yes.
Sir, I have a query, sir.
Okay, so again,
alternate.
Why I'm trying to avoid it? Okay, again, I have to spend a lot of time.
Sir,
okay, so let me.
Sir, in alternate method.
Just a minute. So again, whoever asking this question, I can come to this question in the end, but let me first finish whatever I have planned. Okay. So sorry, like I can solve this question in the end if I have time. Okay. So, but before that, let me complete what I have planned.
Sir, I have another query, sir. In continuity, in alternate method of continuity, there is FA. How we calculate, sir?
Sorry, in alternate method, there is FA.
FA, no, continuity. There is FA term. How we can calculate, sir?
What is your function? You want to, what is your function?
Sir, in previous slide, there is given, sir.
Function definition is given now.
Previous,
We can calculate
in definition, this one, sir.
Which
FA?
What is FA? But no, I still don't understand your question.
Sir,
He is generally saying that actually about the last line.
This one you are saying, right?
Yes, sir.
But
yes,
I have explained it, right? Like
yes,
how...
you explain, sir. I only FA. I have query with FA, sir. How we can calculate FA?
Sir, I think one thing we can recommend, we can do more focus on week 9, sir. Means this year we are revising.
So the thing is,
sir, firstly complete all the things, after that you take.
Yes, sir. Yes, sir. And sir, please get a revise on week 9, sir. It is also most important.
Yeah, I'll come to that. Don't
week 9. Yes, sir.
Yes, sir. Firstly complete, after that you will take it out.
Okay, so so the thing is, the next thing is what? Differentiability, right? So you know the definition of differentiability, how you check whether the function is differentiable at a point A.
Yes, sir.
So when you say, so again, let me tell you, just before checking differentiability, let me tell you, if a function is differentiable, no, I should not tell this one. Okay, let me tell the definition. So so you have a function which is defined at a interval around A. Okay, then you say that this function is differentiable at A if this limit s tends to 0, f of A plus h minus f of A by h exists. Then you say that this limit is differentiable, sorry, this function is differentiable at A. And whatever is the limit, if this limit is, say, if the limit is m, then the derivative, then you say that derivative of the function at x equal to A is m. Okay. And the second thing is, if a function is differentiable at a point A, okay, that means the function is continuous at that point. Okay, so let me write, if a function is differentiable, okay, differentiable implies continuity implies limit exists. Okay, and second thing is continuity doesn't imply differentiability. Okay, so for the second thing, what I can do, I can draw this graph. This, if you take this function f of x is equal to mod x, okay, so this is the graph of mod x, and this is continuous at x equal to 0. This function is continuous at x equal to 0, right? But this function is not differentiable at x equal to 0. Okay, because as you can see, you have a corner here. Okay, so that is basically the third point. So how you can check the differentiability of a function just by looking at, so suppose somehow you know the graph of the function. Okay, again, drawing the graph of the function is not easy for all the function. Okay, for some function it's really complicated to draw the graphs. It's really difficult to draw the graph of a function, but somehow you know the graph of a function. So how you can say that this function, whether this function is differentiable at a point just by checking at the graph. So the thing is, how you can say, if you check the graph, if the graph has no sharp corner. Okay, for example, here you have a sharp corner. Okay, so just a minute. Mute everyone. So suppose you have a sharp corner. Okay, so here you have a sharp corner. So that's why this, so at x equal to 0, you have a sharp corner. That's why this function is not differentiable at x equal to 0. So if in the graph, if you don't have any sharp corner, then you can say that this function is differentiable. And if there is a sharp corner at some point x equal to a, then you can say that this function is not differentiable at x equal to a. Okay, so once the function is differentiable, okay, then you have a tangent line. You have a tangent line at that point. Okay, so suppose you have a function like this. So suppose this function is differentiable at x equal to a. Okay. At x equal to a. Okay. So once this function is differentiable at x equal to, then you have a tangent line at this point. Okay, this is the tangent line of this function at x equal to. What is the slope of this line?
Negative.
Sorry?
Negative.
F dash of a, sir.
That is okay.
Derivative
that is
of
negative, but okay, I was not expecting that answer. Okay, you are correct. The way I've drawn this graph, yeah, slope of this line is f dash a. Okay, derivative of the function at a. Okay, so and now so you know this line passes through this point a,
fa,
and you know this slope of this line is f dash a. So once you know that, you can easily calculate the equation of the line, and precisely the equation of this line is this. Okay, y equal to f dash a times x minus a plus f of a. Okay, because you know that basically it's you know a line passes through one point and the slope of the line.
Intercept form.
Yes, you can use that thing to compute the equation of this line, and equation of this line is y, which is y equal to f dash a times x minus a plus f of. Okay, so
sir, that's a unique tangent, right? The previous only one tangent can pass through that point a comma f, right?
If the function is differentiable at that point, okay, there is one and only one tangent. Okay, if that is possible when you have when the function is differentiable at that point, that is crucial. Okay.
For mod x that you shown earlier, multiple tangents can pass at x equal to 0.
Yes, correct. Because the mod x is not differentiable. Okay, can one of you quickly tell me why mod x is not differentiable?
Sir, due to sharp turn.
No, you use definition. Okay.
Because there are infinite.
Yes, sir.
Because slope is a.
Yeah, Sujay, you tell me. Sujay.
Left at the x equal to 0, left slope of the left line is -1, right line is +1.
Correct. So what I need to do? I need to check this one. So 0 plus h minus f of 0 by h, right? My function is f of x equal to mod x. Okay, so this is limit x tends to 0. So f of h minus f of 0, which is 0, divided by h. So this is nothing but limit h tends to 0 mod h by h. Now, if you compute the left hand limit now here, you will get -1. If you compute the right hand limit, you will get 1. That means this limit doesn't exist. Okay, and since this limit doesn't exist, that means this function is not differentiable at x equal to 0.
Okay. Sir, one point. Can you please go a little up? Just about differentiate those definitions above one. Little bit. No, above. Yes, sir. So second definition, that this should be striped out, right?
Which one?
Means continuity does not infer it is differentiable.
Correct. That's why I gave this example here.
Yes.
Okay. Correct. Thank you.
Sir. For that mod x, when we are checking the differentiability at x equal to 0, sir, you said that one of the limits will be +1 and the other limit will be -1.
Yes.
But sir, at x equal to 0, if we check the limit, then both plus x and minus x will approach to 0 only, na? If you check in that sense.
You check. We have done it n number of times. You try to check it. You try to find the limit of this function. Okay.
Okay.
We have done this kind of problem. So even in this session, if you see this question, right, you try to solve this. Even we have a similar question over here.
Sir, a similar question only. That's why I'm saying.
Yeah. You try to do it. You try to do it. Okay. You use the definition. Okay. If h is less than 0, mod h is nothing but minus h. Okay. So that's why minus h by h is -1. Right. So that's why the left hand limit is -1. So if h is greater than 0, okay, that is right hand limit. Mod h is h. Okay, h by h, which is 1. So that is the right hand limit. Clear?
Yeah, sir. Yes.
Yes. Okay. So now this is slightly okay, because I wanted to do this question fully. Okay. So let me.
Sir, can you please quickly go to week 9? So we have at 8 we have stat session, revision session. So it's week 9 is most important for us.
Yeah, but we have still 1 hour 10 minutes, right?
Yes.
Sir. Please.
Sir, after this question only.
Yeah, this after differentiability, I'll come to week 9. Right.
Yes, sir. Thank you so much.
Yes.
And sir, this type of question came in our quiz too.
Okay, that I don't know, but okay. I see. I am
sir,
not
we will
here.
solve, sir. That's okay.
Sir, you will continue with your.
Let him complete. Yes, sir. Let him complete.
Okay, let me tell you just one more thing. I'm here to revise the concept. I'm not here to discuss the question of quiz or maybe end sem. Okay, this is a revision session. Okay, I'm trying to revise the concept of
Please continue.
Sir, we will solve this, sir. Sir, you can continue to next.
Please continue with your plan, sir.
Okay.
Please give this example.
Okay, so if you can solve, then you can go for a walk and you can come after that. Okay, so let me do it. Okay, so the thing is so you have a function here. Okay, so you have a function here and two things are given. Okay, so two things are given. One is f is continuous. Okay, f is continuous, and another thing is f is differentiable. Okay, and it is given. Okay, but the problem is you don't know what is k, what is l, and what is m. Right? You don't know the value. Okay, so you need to find the values of k, l, and m so that the function will become continuous at x equal to a and y equal to and also differentiable at x equal to. Okay, so the first thing what we need to do here, first we need to check the continuous. So for what values of k, l, m, l and m the function will be continuous. So the continuity, what we need to do first, we need to check
limits.
Not limit, we need to check
defined or not.
Yes,
That value.
f of 1, right? What is f of 1 here?
Kx square.
K plus L. K plus L.
K plus L. Okay.
Plus L, sir.
Yes. So this is my f of 1. So the next thing what I need to do, I need to check the left hand limit. What is left hand limit?
That is also kx plus L.
Kx square plus L.
So if x is less than
K
1,
plus L.
if x is less than 1, what is the value of the function, right?
Kx square plus L.
Kx square plus L.
So this is kx square plus L. So
is equal to
this is equal to k plus L, right?
Yes, sir.
This is the left hand limit, right?
Yes.
So the next thing is the right hand limit.
K plus L plus M.
Yeah, so here x is coming from the right hand side of 1. That means x is greater than 1. So here f of x is what? Lx square plus kx plus m, right? So what is this limit then?
L plus
K plus L plus M. L plus K plus M.
So what I want? I want this function to be continuous, right?
Yes,
so
M is equal to 0.
Yeah. So for that, what I want this limit should be equals to this limit, right?
Yes, sir.
That means K and this limit should equal to this limit, and that is equals to f of 1.
F of 1.
Yeah. So and since these two things are same, I don't need to overwrite. Okay. So I don't need to write it again. So K plus L is basically equals to, right? If this condition holds, this condition holds, then I can say that f is continuous, right? If this condition holds, then I can say that f is continuous. So what I can get from this condition?
M equal to 0. M equal to 0.
M equal to 0.
0. Okay. So this is m equal to 0. We are getting from the continuity by checking continuity, right? So if m equal to 0, then my function is continuous. Okay. But one more thing is given, that f is differentiable also, right? Then I have to go for differentiability, right? So this is now this is 0. Okay. So for differentiability, what I have to do? I have to check limit s tends to
or not.
This I need to check, right? I need to check whether this limit exists or not. Okay. So basically it is given that f is differentiable. That means this limit should exist. Okay. To basically to find out the limit, what I need to do? I need to find the left hand limit, right? Is it correct or not?
Yes,
Yes, sir.
Yes, sir. Yes, sir.
Okay. So let me tell you. Is there any problem?
Left hand, right hand.
So now I want to compute. I want to find the values of K, L, and M so that this function will become a differentiable function. So what basically I check? First I check for what values of K, L, and M this function will be continuous, and from there I check left hand limit and I check right hand limit, and from there I conclude that if M is 0, then the function is continuous at x equal to 1. So the next thing what I am checking, I'm checking if by checking the differentiability function whether I can get some values of K and L. Okay. So this is a limit. So first I need to check the right hand limit. The right hand limit is what? Sorry, left hand limit.
Sorry to interrupt you, sir. Sorry, how you formulate this the line limit h equal to tends to 0, f1 plus h.
I'm checking differentiability at x equal to 1, right?
Okay.
Is it clear? I'm checking differentiability at x equal to 1, correct?
Yes, sir.
And this is the definition of differentiability at x equal to 1, right?
Okay, sir. Okay.
Yeah. So then what I will get in the numerator if h tends to 0 minus
x square plus m.
If h tends to 0 minus, that means h is negative, right? Right. That means 1 plus h is less than 1, right? So then what will be the value of the function?
K square plus L, sir.
Correct. Correct. Yes. Plus L minus K minus L, right? Because the value of f of 1 is basically K plus L, right? So finally what I will get if I take the limit, I will get K h square plus, because this K here I will get K, this L and this L, and whatever K I will get from this term, this will get cancelled with this K, and finally I will get K square plus 2 K h, right? by s. And what will be the final limit?
2k.
2k.
Okay.
Correct. And what about the left hand limit here? Sorry, right hand limit here. Limit.
Sir, left hand limit we take minus h, no?
H tends to 0 minus.
Yeah, but
Sir,
here in
right.
denominator you have
Sir, how come 2k, sir?
minus h.
Because I want this limit to exist, right? When I can say that this function is differentiable, if this limit exists, right?
Yes, sir.
So when this limit will exist, if the left hand limit and right hand limit will equal.
Same.
Yeah. So for that I have to first compute the left hand limit and I have to compute the right hand limit. Then I have to make them equal, right? Is it clear or no?
Yes,
sir.
sir.
I have doubt in the 2k, sir. How come the value become 2k, sir? Because if we apply 1.
So
the final one, sir.
This one, right? You are talking
No,
about
no,
this.
the last, the down. Yes, sir. Here 2k.
Yeah,
Value is
for limit you need to compute two cases, that is left hand limit and right hand limit, right? So you are computing a limit here.
Yes, sir. While computing, if we
No, sir,
substitute
how you evaluated this one? How
with
you,
one, no.
Sir, here h
H is
cancels
1, no,
out, so
sir.
kh plus 2k.
Is
Value will be
zero,
kh
na?
plus 2k.
It's not 2k.
No,
sir.
you to expand 1 plus h whole square. You have to
But
expand
no,
1 plus
sir.
h whole
Then
square.
here we have to do by
Okay,
that
got it.
L
Then we are
orbital,
putting
na?
h value. H value is 0.
Yeah. So
Then it will be 0, no, for whole.
the H value.
H you can cancel, sir.
The value of
Then it will
x,
be.
we are
Canceling the H.
Just
We are
take the
taking h common from
Yeah,
numerator.
Yes.
Yes, sir.
Yeah. H we are cancelling. We are cancelling.
I think she's confused between x is equals to 1 or h is equals to 0. Why we are putting different values?
Is it clear now? I still don't understand your doubt. Like
2k, na?
Yeah, 2k, sir.
2k. Yes. And sir, right hand limit will be 2l plus k, I guess.
Yes. The right hand limit, what you need to do, you need to compute f of 1 plus s minus f of 1 by s. And since again, the main
2l
thing
plus
is
k.
now here s is, you are coming to s from the right hand side. That means h is greater than 0. That means 1 plus h is greater than 1. So now here 1 plus h is greater than 1. So by definition, f of 1 plus h is this thing. Okay. So if you substitute, so basically what you will get, L of 1
Plus
h whole square plus k into 1 plus s plus m minus f of 1. What is f of 1? Minus L minus k minus m, and divided by s. If you compute it, you will get
2l plus k.
2l plus k.
Plus k.
And you can
Sir,
say
can
that.
we directly differentiate it?
Yeah, sir, that is what I did. Directly I differentiated.
You can do that. Okay. So I was going through the definition. Still you can do it. Yeah, correct. So,
I have a small doubt. So why you have taken F1 to be minus L minus K and minus M?
Which one?
It should be minus L in limit h tends from positive side. This one only. So why you have taken minus L minus K and minus M? It should be minus L and minus K.
It is the value of f1.
This is f1, right?
From positive side.
Okay, sorry. F of 1 is k plus L. Yeah.
Yes, sir.
K plus L. And already we have computed that m is 0. Okay, so it doesn't matter. M is 0. We have computed here, right? M is 0.
Oh, okay. Yes.
So eventually what you will get 2k plus n. Okay. And I can say that this limit exists when this left hand limit and right hand limit are equal, right? When these two things are equal, then I say that this limit exists and the function is differentiable at 0 at x equal to 1. So if 2l plus k is same as k, not
2k.
k, just 2k,
2k.
then I can say that this function is differentiable at x equal to 1. This is same as
k equal to 2l.
K minus 2l equal to 0. So from the differentiability, I got that k minus 2l is 0, correct?
Yes, sir.
And m is equals to 0.
Final answer is 0.
So what I need to compute?
Sir.
I need to compute k minus 2l plus m, which is also 0 because this is 0 and m is 0. Is it clear how we are getting?
And sir,
yes,
sir, we will also get individual values of kl and m also if we find the limit.
No, actually, for here you have multiple. So this function can have multiple values of k and m. Okay, because see, I can take k to be 3. Okay, I can take k to be 6 and L to be 3. At the same time, I can take k to be 8 and L to be 4. Okay, so it can have multiple values of k and L. Okay, and one other way to, as someone already mentioned, one other way to do is simply differentiate. Okay, if you differentiate it, you will get 2k x plus L. Okay, and if you differentiate it, you will get
2lx plus k.
2lx plus k, and now you equate it at x equal to 1. Okay.
Yes.
That is another way of doing this. Okay, and what about question number? Okay, let's go to question number 10. Any idea how to solve this question?
Sir, is differentiability applicable on sequences?
If f is the differentiable x is 1 and f be
Is differentiability applicable on sequences?
It's depend. See, this your question is sort of incomplete. Like, what do you mean by whether differentiability is applicable for sequences? What do you mean?
Can we find differentiable points of a sequence?
Line which passes.
No, still it has no meaning. What do you mean by that? Still, you can how you can apply differentiability. What is, you must have a sequence. What you want to do, that is also important. What you want to do for that sequence.
Let's say we have a sequence. We have a sequence of 1 by n square. Then can we find the differentiable point at that of that sequence?
Okay, more or less no, because see, the thing is 1 by n square is a discrete function. Okay, so yes, so there is a different theory for that thing. Okay, so don't go into that because
just
so
ask.
yeah, no. So the question is fine, but the thing is you have to ask it little more precisely. Okay, so
sir, the answer is 2.
Okay. Actually, I was watching the revision lecture, and there ma'am never told me. Ma'am told that yes, we can do it, but she never given any example. That's why I'm asking.
No, that is what I'm saying. Like, you can do it actually. So the thing is, okay, so now actually we are doing differentiability basically on a what you can say mostly on the set of real numbers. Okay. So differentiability so most of the function are, so domain of most of the function are functions is basically R, right? So there is a theory where you can talk about, like, you can basically not differentiability, okay, more or less. So they are actually for the discrete thing also you can talk about differentiability, but okay, so there is more or less in that case most of the function they will have derivative as 0.
Yes, sir. Answer is 2.
Answer is 2. Why? First tell me what. First tell me what this
Sir,
question
we
is
need to
asking.
find the equation,
Because
right? From
y
the
minus
two-point
x,
formula.
y minus y1 equal to m times x minus x1.
No. Don't tell me the answer. What basically tell me what this question is saying. What you need to find.
Say here the curve
slope of tangent
Just
at x equal
a
to 1.
single person.
Sir,
Slope of
we need to
tangent
find the
at x
equation
equal to
of
1.
the.
Abhinandan.
Yes, sir.
Yeah,
So I was
please.
saying that in this question we have given a curve which is differentiable at x equals to 1.
Yes, correct.
And
So
we
this is a
given
curve.
tangent.
This is a curve, and
Yes,
this
sir.
is differentiable at x equal to 1. Okay.
The
So
second information which we are given is that there is a line which is also tangent and it passes from 5,8 and touches the curve at 1,0.
basically 1,0. So it's basically it's saying touches the curve at 1,0. That means the value of the function at 1 at x equal to 1, the value of the function is what?
0.
Correct.
0.
Okay. So
now we have to find the differentiable value at x equals to 1.
yeah, so okay, let me so I'm writing it at 0, but okay, this graph is not accurate, but let me write it as 1,0. Okay, so if it is 0, then it has to be somewhere here. Okay, so okay, so this is 1,0. Okay, next thing.
Line also passes through 5,8.
Yes, so there is a line which passes through 1,0 as well as 5,8.
And it is
slope 2.4 formula. Find the slope of line.
I've slightly made mistake.
So it should be tangent now, so it should not cut the curve.
No, it's not like that. It can cut. It should not cut at that point. Okay.
Yes, sir.
So it's saying there is a tangent line. Okay, let's say this is the tangent line at this point. Okay, at this point, and this tangent line passes through 1,0 and 5,8. Okay.
2-point form, we can find the slope of line.
Yeah, correct. So now what do we want? We want to find the derivative of this function at 1. Okay. You know the slope of this. Yeah, let me complete. Slope of this line. Slope of this line L is same as the derivative of the function at x equal to 1. Now can you find the slope of this line?
Yes, sir.
Yes, sir.
Yes, sir. Y2 minus y1 by x2.
Yes. So the answer is clear, right? This answer of question number 10 is clear.
Yes, sir.
Yes, sir.
Okay, fine. Okay, let me do it. Let me go to Riemann integration. Okay, again, I'm not going. So the thing is, I'm not going into the theory of Riemann integration. Otherwise, it will take a lot of time. Okay, so let me solve a few questions related to Riemann integration. Okay.
Sir, Riemann sum and Riemann integration both are same.
Again, it's depend. No, they are not same. So Riemann sum. So it's depend what kind of Riemann sum you are talking about. Okay, so the left Riemann sum. Okay, this is also a Riemann sum, right? But this is not same as Riemann integration, but because Riemann integration is more or less it will give you the exact area of the under the curve. Okay, so if you apply the left Riemann sum, then you will get some kind of approximation of the area. Okay, so certainly they are not same, but the idea is more or less same.
Okay.
Excuse me, sir.
Yes, please.
Sir, suppose if the function is not defined uniformly, see, in the question number 11, what is given here, in each and every option, the function is defined in another way. It's x plus 5x square like that. Suppose if you have got a function which has split, that is given in our mark 1, sir. In that case, how to proceed, sir? Means I got that doubt.
I'll just let me complete this question. I'll come
Yes,
to
sir.
immediately
Yes, sir.
after that.
Yes, sir.
So
Thank you, sir.
So the thing is, you have a Riemann. So the first option is basically you need to find the left Riemann sum, right? So you need to find the left Riemann sum of this function. So this is your function. So the function is f of x. So this is your function, right? And you need to find the Riemann sum of this function, left Riemann sum of this function on this interval. Okay, so this is now your interval. And what you need to do, you need to divide this interval into equal sub interval into equal 3 sub interval. So what is the length of this interval?
3.
3, right? Not 3.
I mean,
3.33 something.
This is basically 10 minus 1, which is 9. So this is the length of this interval, right?
So
Sir, I said after the dividing.
Sorry?
Both are included, no? 10 and 1. So it should be 11.
The length of this interval is 11.
So 10, sir.
No, sir.
This
10
is
minus
9.
1, sir.
10 minus 1.
9 by 3.
Is 9. Okay. So once we divide this interval into 3 sub interval, basically we need to divide this sub interval. Then what will leave the partition? This is basically 1. Then what will the next 4, 7, 10. So from this partition we are getting basically 3 sub interval 1, 4, 4, 7, then 7, 10, right? So these 3 sub intervals we are getting. Okay. So the next thing what we need to do, we need to find the left Riemann sum. Now we have computed all the sub interval. Okay. The next thing is we have to find the left Riemann sum. So for left Riemann sum, so what value I have to consider for the function?
147.
Left side of the intervals.
The left side of interval. Okay. Left side of the interval. Okay. For the left Riemann sum, I have to consider the left side of the interval. So the thing is, so here the left side of the interval is what? 1, right? So I have to take f of 1 times what I need to take here?
3.
That is the length of the interval, which is 3.
Delta, yeah.
So the next is f of 4 times 3, because here length of all the intervals are same. Okay. So the next one is f of 7 times 3. Okay. So this is nothing but 3 into f of 1 plus f of 4 plus f of 7. And now you can compute, right? What will be the total sum?
Yes, sir, 81.
Yeah, so whatever, yeah, probably 81. Okay, so this is so how
81.
so this left Riemann sum is clear, right? How we are getting left Riemann sum of a function.
Yes, sir.
Okay.
Yes, sir.
So this is so the next thing is you have to compute the middle Riemann sum. Okay, so you have to compute the middle Riemann sum of this function f of x square and on this interval, and the interval is divided into 4 sub intervals. Okay, so let me take f of x equal to x square, and we are taking on this interval 0 to 8, and we need to divide this interval into 4 sub intervals. So what is the length of this interval?
2.
2. Length of this interval, once you divide, you will get 2. Okay. Now the length of this interval is 8. Okay, so then what? So then if we divide this into this interval into 4, sorry, 4 sub interval, then the length of each interval will be 2. Okay. So the partition is 0, 2,
0 to 2,
4,
0 to 4, 4,
8.
6, and 6,
8.
Sir, can I just stop you?
Yes, please.
Sir, is that a question? Like the 4 subintervals, how did you take? Is that given in the question?
It is
It's given in the question.
As you can see, yeah. So 4 subintervals.
4 subinterval.
Of equal length, that is also important. Okay, because why we have divided this length of the interval by 4? Because it is given that the length of all the 4 subinterval, they are same. So that's why we have divided this by 4. And the final answer is 2. So length of each subinterval is 4. So then we have to create 4 subinterval of equal length out of this interval 0, 8. So the obvious size is you take 0, then 2, then 4, then 6, then 8. So now we have 4 subinterval. Okay, 0, 2, 4, 4, 6, and then 6, 8. So now we have 4 subinterval, right? So the next thing is what we need to do. We need to compute the middle Riemann sum. So for middle Riemann sum, what will be the value of the function? Like which value of the function we have to take?
Middle point of the interval.
Average 1.
Yes, the middle point of the intervals. So the middle point of this interval is 1. Middle point of this interval is 3, and the middle point of this interval is 5, and the middle point of this interval is 7, right? So then the final value will be f of 1 times the length of the interval. So the length of the interval is 2. Then f of 3, the middle point of this interval, times the length of this interval, which is 2. Then f of 5 times the length of this interval, f of 7 times the length of this interval. Okay. So if you compute this value, this is 1 square, this is, I guess, 9, this is 25, and this is 49, because f of x is x square,
X
right?
is square, right? Yes.
So finally, if you compute, then you will get some answer. Okay.
84.
Yeah, whatever, like, yeah, you will get some answer. Okay. So, yes.
Excuse me, sir.
Please.
I have one question. If this length of this, the range of this is from 0 to 12, then we will take 1.5, the mid value.
No, sorry. Range. What do you mean by range here?
Not range. The interval is from 1 to 12. Sorry, 0 to 12.
0 to 12.
Yes, sir.
Then your sub interval will be different, right?
Yes, sir. That's what I'm saying.
So
from 0 to 3. My first
It will be from 0 to 3.
Yes,
so
sir. Then what will be the midpoint?
You divide, you take 3 plus 0 by 2, which is 1.5.
Then we have to find the square of 1.5.
1.5, yeah, which is, yeah.
Yes.
Then
So,
you need
f of 1.5 into
yes,
2.
yes. So then what you need to take? You need to take f of 1.5 into 3. Okay.
Into 3, yes.
Then probably 3 to 6. So
yes, sir. Then we will continue.
Yeah, so f of 4.5, then and this.
Thank you.
So it's depend on the interval and how many sub interval you are taking. So yeah. Then what about the next thing is you have this function f of x is equal to 2x. So this is your function. Then you need to find the right Riemann sum of this function in this interval 1 to 9, and you need to divide this interval into 4 sub interval of equal length. Okay. So what is your function? Your function is basically f of x equal to 2x, right? And you need to find the right Riemann sum of this function on this
It will be
interval.
same as the above one, right?
Is it?
8 upon 2. 8 by 2. Oh, sorry. 8 by 4. 8 by 4.
So you need to divide this interval into 4 sub intervals of equal length, right? So what is the length of this interval?
8.
So if you divide this interval into 4 sub-interval, then the length of each sub-interval will be 2, right?
2.
So then the partition is basically 1 plus 3
1, 3,
plus
3, 5, 5, 7, 7, 9.
So then this will give you 4 sub-interval 1, 3, 3, 5, 5, 7, and 7, 9. Okay. So then for the right Riemann sum, you need to consider the
right hand value.
Right side of the
right side of the interval.
5, 7, 9.
Yes.
Okay. So this is f of 3
into 3
times the length of this interval, which is 2.
Into 2.
Yes.
Into 2.
Then f of 5 into 2. F of 7 into 2. F of 9 into 2. Okay. So this will give you the final value. Okay.
Sir, excuse me, sir.
Yes, please.
Sir, in this same question, if interval given like 1 to 8, then ask 4 sub interval. So we 7 divided by 4. Is it possible, sir?
Yeah, this is possible. But you have then you need to do a lot of calculation. Okay, so again, what will be the length of each sub interval? 8 minus 1 by
4,
right? 7 by 4.
Yes.
Right. Then what will be the partition? First 1, then
1 plus
7 by 4. Okay. Then 1 plus 7 by 4 plus 7 by 4. Okay.
Means
this is
7 by 2.
Yeah, 7 by 2. Correct. Then
okay, sir. My doubt clear, sir.
Yes. Then you have to go up to 9. And not probably 9. Yeah.
Sir, how we are choosing a left, right, or mid value?
That is depend on the what Riemann sum you want to compute. Okay, it's depend on the question. So in the question here, it is given that you need to find the right Riemann sum, right?
Thank you, sir.
So that's why we are taking the right Riemann sum. So in the first question, it was given you need to find the left Riemann sum. That's why, as you can see in the first question, we basically took all the left points of this interval 1, 4, 7. And in the second question, it was given the middle Riemann sum. So for the middle Riemann sum, you need to take the average. You need to take the average of both the end points of the interval. Okay. Clear?
Sir, one doubt, sir.
Yes, please.
Sir, if 7 by 4 is our length, can't we take as a fraction, sir?
Yeah, you can take the fraction. That is what I said, right? You can take the fraction and you can compute. But again, you have to do a lot of calculations.
Okay,
yes. There is nothing special about this 1,9, this 1, 3, 5, 7, and B. See, we have taken this in length of the interval so that you don't have to do much calculation. Okay.
Yes.
That is the thing. If you take some arbitrary interval and some arbitrary length, then probably you have to do more calculation. Okay.
Okay.
But the idea is same. Okay. So the next question is option 4. So here what you need to do, you have a function f of x equal to x square, which is defined on the interval 0,6, and you need to divide this interval into 3 sub-interval of equal length. Okay. This is the function, and this is the condition on the interval. And using this condition, you need to find the trapezoidal Riemann sum. Okay, you need to find the trapezoidal Riemann sum. So anyone, how we can find this? So this
what is trapezoidal Riemann?
So it would be half of the right and left values.
Correct. So someone asked me how to what is trapezoidal. Let me. So this is defined on 0,6, and we need to divide this interval into 3 sub-interval, right?
Yes, sir. 3.
So what is the length of this interval?
2.
6.
This one is 6.
This yeah, correct. So this is
This is
6,
six.
and if I divide by into 3 subinterval, then the length of this subinterval
Will
will
be
be
2.
2. So finally, what will get? 0, 2, 4, 6.
0, 2, 4.
6.
Yes, sir.
So so our interval subinterval will be 0, 2, 2, 4, 4, 6. Okay. So basically, basically for trapezoidal, what you need to do? Okay, if you let me do it. Okay, so this is the graph of a function. Okay, you draw a trapezoidal here. Okay. So this is let's say this is your interval A, B. Okay. So this is f of A, this is f of B. What is the area of this trapezoidal?
Half h into a plus b.
Distance between two parallel line and sum of.
Correct. What is the distance between these two parallel lines?
Interval length, which is 2.
This is A, this is B. What is
B
the
minus
distance?
A.
F of b minus f.
B minus
Oh,
A.
sorry, b minus
B
a.
minus A into f of A plus f of B by 2, right? This is the area of this trapezoidal, right? Is it correct or no? Yes.
Yes, sir.
So basically, we are going to do the same thing here. Okay, we'll do the same thing here in this interval. Okay, what we'll do? What is the length of this interval? 2, right? So B minus A. So if we consider this as A and this as B, what is B minus A? B minus is 2. That is the length of the interval, right? Then f of B plus f of A by 2, right? Which is nothing but f of 2 plus f of 0. Even you can write in the reverse order, f of 0 plus f of 2 by 2, right? Then what is the length of this interval?
2.
Again, f of 4 plus f of 2 by 2. Okay. Then
Again, in the
2 times f of 4,
4
f of 6,
by 2.
2. Okay. So this is the trapezoidal Riemann sum of this function on this interval. If you divide this interval into into 3 sub interval of equal.
3 subinterval. Yes.
Is it clear?
Yes, sir.
Yes, sir.
Into that 2 into a minus b can be 3 also, 4 also, based on the interval difference.
No, can you repeat? Sorry.
This a minus b, that 2 we have calculated.
Yeah,
Here
it's
it is coming as 2. It can be 3, 4 also.
It's depend. If you so in the question it was given that partition this interval into subinterval 3 subinterval of equal length, right? But instead of that, if I partition this into 2 subinterval of equal length, okay, what I'll get? I'll get 2 intervals 0, 3, 3, 6, 3, 6, right? And in this case, my trapezoidal sum will be what? F of 0 plus f of 3
plus
by 2 times 3.
2 into 3.
Yes, plus f of 3 plus f of 6 by 2.
F of 6 divided by 2 into.
Correct.
Got it, sir.
So this is the trapezoidal Riemann sum with respect to these intervals, and this is the trapezoidal Riemann sum with respect to these intervals. Is it clear?
Yes, sir.
Sir, which option is correct, sir, here?
Yes, sir.
Sorry. Okay, I don't know. Okay. So the thing is, you need to compute.
Second one is correct. Yes, we did, sir.
Yeah. So I guess.
Is it only the middle second one, sir?
I guess only either option 1 or one of them is correct. Option 1 or 2. I don't.
Sir, option second is correct. One we have got 81, sir.
Okay,
Sir,
then
I
option
Okay.
1 is
Option 2 is
incorrect.
correct.
Option 2 is correct, but
Option 2 is correct.
I'm pretty sure option 3 and 4 are incorrect because I gave
Yes,
some
sir.
arbitrary number.
Yes. Yeah.
Yes,
sir.
sir.
Option 4.
3 is definitely
Instead of trapezoidum, if a rectangle is asking, then we calculate like f of b into f of a. That's fine, sir.
Yes. But okay, so the problem with the rectangle is it basically why usually don't we take rectangle Riemann sum, or it more or less it gives very bad approximation of the area, whereas this trapezoidal Riemann sum actually it's give very good approximation of Riemanns.
Okay, sir. Okay.
Yeah.
Sir, do we have for
second
another
option is for
geometric?
116.
Sorry.
Sir,
Second.
apart from so just a minute. Apart from trapezoidal, do we have any other other geometric figures? Triangle, parallelogram like this?
Yeah, you can take, like, it's depend on you. You can take lot of figure and
So we have to use just area. Suppose there is a suppose they ask the triangle Riemann sum.
the thing is we are not going to ask. As far as I know, I guess these 4 things are there in your syllabus. Okay, there are so many other things, but we will not ask in the exam. Okay, so as you said, you can take so many figures and you can approximate the area of the function.
So, but these 4 are in our syllabus.
Yes.
So, sir, here this critical thing is we have to divide that range in interval in proper way, right? Because if we miss something there,
then definitely you will get some.
Definitely on overall.
Yeah. So
Yes,
again,
sir.
as I said, these functions are pretty easy. Okay.
Yes, sir.
You don't have to do much computation. The intervals are also very small. Okay. So the thing is, everything is easy. You have to do it carefully. Okay. So
yes, sir.
Yeah. Okay. Probably option 2 can also be wrong. Okay.
Yes,
I'm not
sir.
sure.
Option 2 is wrong. It is not coming.
168 it's coming, sir.
Okay, let me check the answer. Actually, I have changed.
No, 178 is coming.
168 is coming.
No, option 2 answer is 168.
Yes, sir.
Yes, sir.
168.
Yes, sir.
Yes.
Even in the mock exam also, sir, the 4 options which is not matches to the answer. So.
Yeah. Please. Yeah. So again, like I as far as
that's why I got the doubt, sir, even in mock.
Yeah. So the thing is, okay, I too actually. So
the 4 options are incorrect, no, sir.
Yeah. So
okay,
so the thing is, so these 2 questions actually I have taken from some previous year question paper, and these 2 questions I have added.
Another question paper. Okay.
Yeah. So I have added this question paper. So I randomly put some numbers. Okay, I really didn't check whether these are correct or incorrect. Okay.
So, sir, in such cases, suppose we in exam, suppose there are all the 4 options are wrong, and
then you should. That is. So we don't do it intentionally. Okay. So then this is a mistake from our side, and you will get bonus mark for that. Okay. So don't worry about that.
So in case if and only if we try to attempt it, right?
No, how you can attempt it? Okay.
No, suppose we got suppose here we are getting 168, but in option there is a 178.
Either
so
you will
we
get
think that
no
approximation.
No, that is certainly, it's not a correct way to do mathematics. You see, if your answer is 160, if certainly it is given in the question, okay, you take up to some 3 decimal digits. Okay, that is a different thing. So if your answer is 167 and it is given that 168, so this is not correct, right? You cannot write 168 in place of 167 because 167 is very close to 160. Okay. So that is not possible. So okay, so again, as I said, we don't do it intentionally. If certainly we are doing it in
okay, sir,
likely we'll do it by mistake, and in that case either we'll ignore that question or you will get bonus mark.
Okay.
Sir, suppose if it is given f of x square in 0 to 2 interval and some other 2x in some other interval, if it is splitted like that, sir,
then you have to do it accordingly. Okay. Then
we
you
have to calculate for each and every case, and finally we have to sum up.
then you have to do take the function. Okay, let me since you have asked this question,
just give the idea, sir.
So suppose,
so in each and every interval we have to calculate the left Riemann sum, and finally we have to add it. Is it correct, sir?
Yes.
Okay.
Yes, sir.
That's what I did, sir.
Doubt.
Yeah. So suppose, okay, let me do it. Let's say this is your function in this interval 0 to 3, right?
Okay, sir.
And this is x square in this interval, let's say 3 to 6, right? And you want to find the, let's say, right Riemann sum. Okay. You want to find the right Riemann sum, and on this interval 0 to 6 by taking 3 subintervals of equal length. So if you take 3 subinterval of equal length, then what you will get?
Each interval 2.
0 to
2, 4.
2, 4 and 4, 6.
4, 6.
So for the first case, what you will get? The length of this interval 2 times f of 2, right?
Yes, sir.
Which is so what is f of 2 here? Which is 2, right? Then again length times f of 4.
2 into f of 4. 4 is 16.
Then we have to choose f of 4 accordingly.
Yes, sir. Yes, sir. That's what I did, sir.
Yes.
To confirm that I'm asking. Thank you.
So again, you have to take the value of the function.
Yes, sir. Yes, sir. Because the options were not matched. That's why I got that.
Yeah. Fine. Yeah, it's actually a mistake from my side. Yeah.
Thank you.
Sir, I have one question. Out of 3 Riemann method, which of the optimum method to find?
No. So again, there is no optimum method, but I guess in most of the cases, this trapezoidal rule is probably the best method. But some of the cases for some of the function, maybe this left Riemann sum can give you better answer. But for most of the function, I guess trapezoidal Riemann sum is better.
Okay, sir.
The area under curve.
Sorry?
It is to find the area under curve.
I made some mistake. Fine. Yeah. So basically, it's basically to not area under. Yeah. So to get an approximate value of the area under the curve. Okay, this right Riemann sum, left Riemann sum, they will, please mute yourself. So this left Riemann sum and right Riemann sum, they will give you the approximate value of the area under the curve.
Thank you, sir.
So okay, so the last thing since I have
Sir, the last slide you have done for that the different for x and x square, the function you have chosen for different interval. Sir, if we draw the function, then one side of the interval is for one portion and another side of interval for other portion. Na? For 2, 4.
Yes, sir. Instead of 2, 4, we have to calculate for 6 and 4.
Calculate
Right side, no, sir.
Right.
Then
4 is belonging to the interval in 3 to 6. That's why it happens.
So this is, I have missed one more thing, 2 into f of 6. Okay. So for this interval, in the right hand
side, sir, it's correct. 2.
You have 0, right? So I have taken f of 2 here. Okay.
Yes, sir.
In this interval, in the right hand
Sir,
side,
can you just explain this concept once again? I have a little confusion, like this trapezoidal rule and this. Very.
No, I was explaining this for last 20, 30, 20 more than
No,
20.
the last steps only what I am asking for.
Which one?
Yeah, this example, this x square.
So this is actually what we were doing. We are trying to find this right Riemann sum of this function on this interval 0, 6. Okay, and how we are finding this right Riemann sum? By taking 3 subinterval of equal length. Okay, so what is the length of this interval?
6.
6.
Yes.
So then if I take 3 subinterval of equal length, then the length of each subinterval
Will be 2. Yes.
2. Okay, so that's why we are getting
Okay,
3
so by division, we like whichever number we get, we will just use that as a multiple factor.
Correct.
Okay,
So
okay.
again, so for the first interval, you are getting f of 2, right? So
Yes.
then you go and check what is the value of the function at 2. So by the definition,
Okay.
the value of the function is 2. Okay. So here
Okay.
you have f of 4. By definition, the value of the function is what? F of 4 is?
Oh, okay. That is x square. That's why we are receiving this.
This is 4
Okay,
square.
okay.
This is
Yes,
16.
yes. Got
Then
it.
this
Yes.
is 36. Then you have
Yes,
to
yes.
take accordingly.
Okay, okay. Yes. Thank you, sir.
So, okay, so let me take the final thing. So I just want to do this integration. I guess integration by part. Okay. So,
Sir, before this, do we have the time to accommodate that question on mock on Riemann sum?
Which one? Which one?
On mock, there was a question.
Let me check.
I think
have you okay, just a minute. Have you found the solution? Like because I can go there, I can solve that, but if you have checked the solution, then probably.
The solution is uploaded, is it?
Yes, yes. Solution.
Okay. Then we will check that. I mean,
just check it, or you can ask me like.
Sure,
sir. One question, sir. Sir, the computing the area, sir, is the graph must have to be, I mean, continuous, no, sir?
For this course, take so in theory, actually, even you can compute the area of a discontinuous function, but again there is some condition on the discontinuity. If that is discontinuous on some finite number of points, then you can compute. Okay, for this course, you assume that all the functions are continuous. Okay.
Okay, sir.
Yes. But again, if you go into some slightly deeper theory, then actually you can compute the area of discontinuous function.
For our Riemann sum, sir, when I do a Riemann sum, so Riemann sum is always, sir, applicable in continuous function, or is it can apply in any function?
That not any function. You cannot apply for any function. But okay, so again, like so there is a concept called measure. Like you can find if the measure of the set of discontinuity. So you have a set of discontinuity. If the measure of that set is 0, basically you can apply Riemann sum. So in particular, what I am trying to say that if your function has finitely many discontinuities,
so then we are approximate those interval as the discontinuities will be removed, and then we apply Riemann sum on those individual interval.
Correct. Yes.
I got it.
Okay, so
you were telling something.
Sorry, yeah, integration by parts. Yeah.
Yes.
Okay, so basically there is nothing here. So let me do just tell me. Just recall something. Okay, it's more or less easy integration by parts. So how you do the integration here? What is the idea behind this integration? So you have a function like this, u into dv, right? So u is a function and v is a function. Okay, sorry. Okay, what is the integration of this one? Am I audible? Have you read?
Yes, sir, you are audible.
Yes, sir.
Yeah,
Yes,
so
sir.
U square by 2.
u
UV minus
V minus integration
V du.
Yes, sir.
Yes.
So, and the thing is, okay, so this is fine, but how you choose this u and v? How you choose?
Eyelet.
Yeah, so as many of you said eyelet. So this is something.
Yes, eyelet.
something you need to remember, otherwise otherwise you may lose few times in your exam. Okay, it's
Sir, in integration, will those complex questions of class 12 and above come? Or
Can you
will
repeat?
simple in integration, will those complex questions
No,
of
no, no, no,
class
no,
12
no, no,
where
no.
we have to solve like root 10x and etc.
No, no, no. The integration will ask very, very basic question like sine x, sine 2x, sine 3x, something like that. Okay, we will not go to some complicated trigonometric function. No. So the thing is, first is inverse. First one is inverse trigonometric function. Okay.
And then logarithmic function, then algebraic, then
Then you have
trigonometrical, then
logarithm. Yes.
exponential.
Then you have algebraic. So here you have something like sine inverse x, cos inverse x, and here you have log, and now you have algebraic. Algebraic is something like x square, square root of x. Okay, then you have trigonometric function, which is t is basically trigonometry, which is sine x, cos x, and the last one is exponential. Okay, so the last one is exponential, like e power x, maybe 3 power x. Okay, something like that. Okay, and what is u? How you choose u? So choose u as whichever comes first in this list. Okay, comes first in this list. For example, if you have x, suppose x log x. Okay, so as you can see, what is x? X is algebraic function, right? Correct?
Yes, sir.
And log x is basically this L, like logarithm function. So basically log x comes before a. Okay, so that means here you have to take u, your log x, and v is what? What is v? So dv is x, right? Then what is v?
Yes.
X square by 2. This is how you do. So any doubt, or do you want me to solve one question?
Yeah, one question.
Yes, sir. Can you give me?
Sir, yes, please, one question.
Please, one question.
Okay, so let me take maybe one question.
10 input. So 10 into x.
No, I'll take a simple one.
Integral of log x.
So let's say,
So this is not simple. Here, applicability of ideal becomes it is bad.
So what is u here? What function you take as your u?
Cos x.
Cos x.
Cos x, right?
Cos x.
So u is cos x.
V e to the power.
So and dv is
E to the power.
dv is cos x.
Ex.
dv is cos x. What that means? B is what? If the derivative of a function is cos x, then what is
Sin x?
Sin x. No, sin x.
Sin x.
Sin x. Okay.
Okay. So your u is cos x and b is sin x, right? Now you can apply the rule. What is this? U times b. That is okay. I guess I made mistake.
Yeah, u was
Yes, sir.
dv
You have to take e to the power.
e to the power
Yes,
x.
sir, e to the power x.
That means b is also e power x. So then what we need to do? We need to multiply u times x, which is cos x times e power x. And next, what you need to do? What is this?
Integration ddx of e to the power x. Now in e to the power x, derivative of e to the power x.
E to the power x.
E to the power x and derivative of cos x, that means minus sin x.
Minus sin x, right?
Then we have
Sir, what is the formula we are using here?
This one, right?
Okay, got it.
Yeah.
So is it better to initialize I as this function? Because it would not we have to initialize I equal to e to the power x cos x. Because it would not.
Yeah. That is what I am going to do. Okay. So again we need to apply this
minus sin x. So minus.
So then what? Okay, just let me do it. Okay, so this till now this is fine, right?
Sir, minus sin x.
Sir, tan will be minus in between. This is.
Oh, then I will get here. I will get plus, right?
Yes, sir.
Okay. So again, I need to do the same here, right? So what I got e power x cos x is this, right? So again, I need to compute this value, right? Okay, please mute yourself. I'm getting some noise. Okay. So if I do this one, then what I will get?
Minus ex cos x.
No, what will be the integration of this one? Cos
x into
sin x
into the
sin x times e power x
plus
right?
minus
minus
e to the power x cos x.
Cos x, correct. So now what I will do, I'll replace this one over here. So if I replace this one there, what I will get? I'll get e power cos x, which is nothing but cos x times e power x plus sin x times e power x minus e power x cos x. Now I can take this one to the left, right? What I will get if I take this one to the left?
2 times
e to the power x cos x integration.
So if I divide these two, then what I'll get? Half
of cos x ex cos x plus
cos.
ex sin x.
Okay, this is what I. Okay, you can similarly you can try other questions. Okay,
Sir,
any other?
I have one now. So not related to the course, but I have received only one hall ticket of 2 subjects.
Okay,
yeah, so other one is left. Other hall ticket we will receive soon.
Then okay, in that
the
case,
same date.
Yeah, it will be on the same day. It will be in afternoon session.
So, hello, sir.
Yes.
See, I have query in continuity related to alternate methods, which I earlier asked to you.
What is your doubt?
FA, function of A, I think, like.
This one you are talking about, this another definition, right?
Yes, sir.
What is your doubt?
Please repeat, sir.
So basically what I was trying to say, you can say that a function is continuous at x equal to a if whenever you take a sequence xn which converges to a, if it implies that f of xn also converges to f of a, then you can say that the function is continuous at x equal to a. Okay, so the thing is, whenever you get a sequence which converges to a, if it implies that f of xn also converges to f of a, then you say that the function is continuous at a. Okay, so you have to do for all the sequence. If this condition holds for all possible sequence that converges to a, then you say that the function is continuous at a. If somehow you can get a sequence which converges to a but f of xn doesn't converges to a, then you can, if you have maybe you have 1 lakh sequence which converges to a and f of xn converges to f of a. But if you can find one sequence which converges to a but f of xn doesn't converges to f of a, then from one sequence is enough to say that this function is not continuous. Is it clear? Hello.
Sir, that above three
okay, sir.
conditions are easy to understand.
Yeah, that's why from the very beginning I have tried to ignore it. Okay.
Sir, can you explain
Sir, one more doubt
example,
regarding
sir?
that boundary condition. Sir, you asked me to ask at end of the lecture.
Yeah. So,
sir, where is that question? Can you please scroll down or scroll up?
Which one? Which question?
That boundary on R. I think it is after this only.
Bounded on R.
Yes, sir. Sir, my query is, sir.
Okay, I guess this one, right? Just let's.
No, sir, not this one.
I
got it. I think there are four. There were four conditions.
Yes. Continuity, I guess.
Yes, sir. After continuity.
Yes.
Sir, this one, sir. So we have our range is
Not
from 0
range.
to 1.
Actually, what do you, okay? Let me tell you what do you mean by bounded on R. Okay, so basically, this function is what? This function is from R, right? Right. So in this domain, okay. So we are taking on R means we are considering this as your domain.
Okay.
So when I'm saying, so if I say this function, whether this function is bounded, okay, bounded on 1, 10, okay, then you have to consider this function from 1, 10 to some R, okay, and you have to check whether on this set whether this function is bounded.
Okay.
Yeah.
So got it.
Yes.
Sir, actually, the critical points, saddle points are remaining from week 9. So tomorrow we have week 10 and 11 revision session.
Sir.
Yeah. So
sir,
again,
can we continue on that?
Oh, okay. So it's almost impossible for me to complete all the things. Okay, whatever it was possible, I have more or less completed.
Okay.
But sir, earlier you said about the regarding range, the bounding and unbounding.
Sorry, can you repeat?
Sir, you said about the related to bounded function with the range.
Range is depend on the domain, right? If you take some different domain, the range will be different, right? So with respect to this domain, okay, you will get a range, right? If I change my domain from 10 to 100, then I will get a different range, right? So it's saying that if this is the domain, okay, whether the range set is bounded or not, okay, you will get some range, right? With respect to this domain, you will get some range, right? Okay, then it's basically saying whether this range of this function with respect to this domain, whether this set is bounded. So it's for option 3, it's saying that whether the range of the function, okay, range of the function with respect to domain R, okay, whether that set is bounded or not.
Yes, sir.
Sir, will you upload, sir, this PDF?
Yes, certainly I'll upload.
Excuse me, sir.
Yes.
Okay.
We all are facing the problem in the algorithm part. So we all request to in the previous session to conduct a session on the topic, and as well as in the previous session. And sir told that if we still are facing problem, they will conduct the session. So
the next session is so the next session is a revision session about this week 10, 11 concept, right?
Yes, sir.
So yeah, so there.
Sir, can we have yesterday this session?
Sorry.
Of algorithm, can we have a discussion session for algorithms here tomorrow?
Sir,
because tomorrow is no math.
Sir, if possible, to sir,
if possible,
arrange a session, sir, for only 1 hour.
Okay, so then I will ask maybe I'll discuss with Srikanth and PK.
Yes, sir, please, sir.
So when is your next revision session?
Sir, day after tomorrow.
Day
Friday,
after
5
tomorrow,
to 8.
sir.
No,
Okay.
it's tomorrow.
Day after tomorrow is your next revision session. On
Yes,
when,
sir. For
when,
week number 10 and 11.
Sir,
No, sir, it is tomorrow only.
Sir, in the revision session,
Sir, it is
there will
tomorrow
be
only.
something revision, not for questions. Sir, we want to question.
I
from-
understand. So you want some separate session. So tomorrow is revision session,
Yeah,
but
we want to discuss the question.
But in our calendar, it is showing a day after tomorrow, not tomorrow. On
Yes,
the 5th
tomorrow
of
is no
August.
math
Tomorrow
session.
is
Yeah,
showing
tomorrow is
here.
not for math one. Yeah.
Yes.
It is on the 5th August.
Yeah, on the 5th, day after tomorrow.
okay, then I'll ask, like, if it is possible, then I'll discuss. So right
Sir,
after
please,
this
sir.
session,
Yes,
yes, I'll discuss with them.
Sir, it's humble request, sir, for our.
Yes. Okay, I'll discuss with them after this session.
Okay, sir. Thank you.
So how we will got updated, sir?
No, if there is a session, then certainly you will update it by tomorrow morning in the calendar. Okay, maybe
Calendar.
not. Yes, then by afternoon, because tomorrow morning certainly we can't take. We'll take
Yes, sir.
session.
Anytime, sir. We already are
anytime.
Anytime, sir. Anytime. We
Yeah,
all
yeah.
are ready.
You can leave. Like whoever wants to leave, he can leave. Yeah. So
Thank you, sir.
then we'll upload it by afternoon. You can see, like, you can see if there is no collision, then probably you can see in the
Morning.
Yeah, in the calendar by afternoon. Okay, the link.
Okay.
Okay. Thank you. Yes.
What last question?
Sorry.
Question, sir. Sir, if we have a constant sequence like a 2 a sequence of 2.
Sorry. Can you repeat? It's because some kind of.
If we have a constant sequence like 2 and it is continuously on 2, so is this sequence convergent or not?
Yes, it is convergent. It is convergent to 2 because as n tends to infinity, the value is basically 2, right?
Yes, sir.
2. So this is A1, this is A2, this is A3. So as if you increase this n,
Yes, sir.
n is basically 2, right? So this is a convergent sequence.
On quiz 2, sir, that we have the sequence of n. So n as a divergent, n cannot have any other
Okay, just can you repeat, like, some background noise or maybe some kind of.
Sir, one moment, sir, please. I am just getting that question, sir.
Okay.
That is quiz 2, yes. Quiz 2.
Sir, here the A1 equal to 2, A2 equal to 2, but it is exactly 2, not approaching to 2, right?
No, if it is exactly 2, then it's more than approaching 2, right?
Okay, sir.
Okay. What it's saying, it's closer and closer to 2, right? So that means closer means what? The distance is less. So here the distance is 0. Okay. So then you have the best possible scenario, right? Yeah.
So there was a question, sir. Sir, in quiz 2, sir, we have a question like, moment, sir. Yes, sir. The sequence an equal to n has no convergent subsequence. So, sir, is it true, sir? Can we not to create a subsequence of a constant sequence from any from n equal to n sequence, and cannot we say that it's also a
No, this sequence is convergent, right?
Yes, sir.
So if you take any subsequence of a convergent sequence, okay, it will convergent. So
and given was an equal to n.
Yeah, so then if you take any sequence, any subsequence, okay, if you take any subsequence of this sequence, okay.
Not yes, sir.
This is the sequence, right? If you take any subsequence,
it is saying not any. It is saying that no.
Yeah, Yeah, basically it's saying no subsequence. It's basically saying if you take any subsequence of this sequence, then it cannot be a convergent sequence.
So now written is clearly like the sequence an equal to n has no convergent subsequence.
Has no convergent subsequence, right?
Yes, sir.
Yeah, that is what I am saying. Now, if you take any subsequence of this sequence, okay, it cannot be convergent, right? Because if you take some subsequence 2, 4, 7, 8, 9, 100, so after eventually it will go towards infinity, right? If you take some sub collection of this number, okay, some infinite sub collection of this number.
But can we make a constant sequence from?
No, that's constant sequence is not a subsequence, right? If you take this sequence a1 equal to 2, okay,
yes, sir.
a2 equal to 2,
yes,
a3
sir.
equal to 3. This is not a subsequence of this sequence, okay. This can't be a subsequence of this sequence. See, the first term is 2, right?
Yes, sir.
Then for the next term you have to take a term which is coming after 2. Okay, you cannot repeat something. See, if you take this sequence, let's say 1 2 3 1 2 3, okay, 1 2 3, like this, okay. So suppose you have taken this sequence, this term, so you are taking some subsequence of this sequence. So the first term of this subsequence is, this is my sequence, okay, I'm taking a subsequence bn, okay.
Yes.
So the first term of the subsequence is 2. So that means I have taken this one, right?
Yes.
Then you have a 2 after 2, this 2, right?
Oh.
Then I can take this 2, okay, I have taken this 2, okay. Then b3, I have a 2 here again, then I can take 2, okay. And so here what is the problem? You have taken this 2, right?
Yes, yes.
So in the subsequence you don't have any 2 after this, okay, so you cannot take any 2 in a2, so a2 cannot be 2, so a2 has to be 3 or some other number which is coming after 2, or maybe 100. A2 can be 100, a2 can be 1000, a2 can be any natural number which is greater than 2, but a2 cannot be 2, and also a2 cannot be 1. A2 cannot be 1 also, because 1 is coming before 2, okay, 1 is not there after 2.
Okay.
Is it clear?
Okay, sir. Okay, sir. I not understand. Okay, sir. Thank you. Got it, sir.
Thank you. Okay.
Hello. Thank you, sir.
Hello.
I would like to about Riemann sum. Facing some trouble there.
सर प्लीज कंसर्न करिएगा जरूर सर सेशन के बारे में.
हाँ.
Okay, sir. Thank you.
Can I ask one question from logarithmic?
What is your doubt, logarithmic?
Actually, sir, I have shared the PDF in which there is a question. It was said that a person saw a cosmic signal that was dangerous for us. So there were 2 logarithmic equations were given that were fine to neglect them.
Can you tell me question number, like activity graded or something?
No, sir. Actually, this question is. Wait a minute, sir. Can I share my screen?
No, I don't think you need. I have to ask to the studio team to allow you to share your screen.
Sir,
yes.
I am actually facing some doubt in Riemann sums.
What is your doubt?
Sir, I would like to can you explain in brief how to solve the Riemann sum?
That I have explained in this session, right?
I could not understand. That's why I'm saying.
Sorry, which part is not clear to you?
You solved the question, right? That one, there are 4 sub-intervals, right? So I couldn't understand that part.
No, which basically in that sub-interval, like I've explained it 2-3 times, right? If you have some doubt while explaining it, you should ask at that time, right? Because again, I have to repeat the whole thing completely.
Okay, sir.
Hello.
Just a minute.
Hello.
Yeah, just a minute. Okay, I guess what happened to that slide? Oh, I guess I have removed that thing. Yeah, so you had 4 questions, right? Some left Riemann sum, right Riemann sum, and middle Riemann sum, and trapezoidal Riemann sum. Yeah, yeah. So for the left Riemann sum, you always have to take this left hand side, right?
Yeah.
Correct. And you have to take the value of the function at this point, the left hand side of the interval. Okay, and you have to multiply with the length of the interval, right? You have to do it for all the intervals.
Okay.
That is the left Riemann sum. So
Okay.
so initially it was given that you need to find the Riemann sum of left Riemann sum of the function at this interval by splitting this interval into equal 3 subinterval. Okay, so the first thing is how you split this interval into equal 3 equal subinterval. Okay, so the first thing is you need to find the length of this interval, which is 9, right?
Yes.
So if you want to split this length into 3 equal lengths, then you have to divide by 3, right? This is 3. So then you start with 1, then you add 3, you will get 4. Then you add 3, you get 7. Then you add 3, you get 10. Okay. So you are getting 4. Now you are getting 3 subinterval, right? 1, 4, 4, 7, 7, 10, right? So for this interval, you are basically trying to find the left Riemann sum. So
Yes.
this is the left point of this interval, right? So you need to take the value of the function at this point, left point, f of 1, right?
Yes.
Times the length of the interval, which is 3, right?
Yes.
For the second interval, you need to take the left hand side again, because you are computing the left Riemann sum. So that is f of 4 plus times the length of the interval, which is f of 4 into 3. Okay. And similarly for this interval, f of 7 into 3. Okay, and suppose instead of left interval subinterval, right, so instead of left Riemann sum, suppose it is asking you to compute the right Riemann sum. Then what you have to do? Instead of taking the left endpoints, you need to take the right endpoints.
Okay.
So instead of what you have to take, so instead of if you want to compute the right Riemann sum, instead of taking f of 1, you have to take f of 4. Okay, f of 4 times the length, f of 7, then for the second interval, f of 7 times the length, then f of 10 times the length.
Okay. Sir, if it is said middle interval, then
you have to take the middle point.
Okay.
If it is asking for the middle Riemann sum, right? Suppose it is asking the middle Riemann sum, then you have to find the middle points of this interval. Okay, for this interval, what is the middle point? 4 plus 1, which is 5 by 2, 5 by 2, right?
Okay. Yeah.
This is 11 by 2. This is 17 by 2. Then the Riemann sum will be what? F of 5 by 2 into 3 plus f of 11 by 2 into 3, f of 17 by 2 into 3. Okay, this will be the middle Riemann sum.
Sir, understood.
Yeah. And what about this trapezoidal Riemann sum? Is it clear to you how we are computing this trapezoidal Riemann sum?
Sir, I am little clear, sir. You can explain once more.
No, so the thing is, again, I have explained it.
By 2 we have to do, right?
So the thing is, I will suggest you can go and rewatch the recording session. Okay, I'll suggest you try to see whatever I have explained there. You try to see again. So if it is given, suppose you need to find let me quickly recall, but I will suggest you go and check the recorded video. Okay, so suppose you want to find the trapezoidal Riemann sum of this function on this interval 0,6, and it is given that take 3 sub interval of equal length. Okay. So this is one interval you will get 0, 2, 2, 4, 4, 6, right? So what is the trapezoidal Riemann sum? So if some interval is given a comma b, then for this interval the trapezoidal sum is basically what? B minus a times f of a plus f of b by 2, right? So for this is your interval, right? So what is b minus a? That is the length of the interval, which is 2. And then what you need to compute? F of a plus f of b by 2, which is f of 2 plus f of 0 by 2, correct? And similarly you have to repeat for this interval and this interval. So 2 times f of 4 plus f of 2 by 2, and similarly.
Okay, sir. Understood about this.
Yes.
Thank you.
Yes, thanks.
Can you please share the slide, sir?
Sorry? Yeah. I'll do it. Yes.
So, sir, can I ask a question from mock test?
You check the solution of the mock test.
Yes, sir, I checked it.
Yes.
I didn't get one question, and it is not from week 6 to week. It is from week 4 only.
Okay, fine.
So
That
can
is
I
fine.
ask?
Yes, please. Let me open the solution. Which part?
8. Question number 8.
Yes.
We have to find D from that question. There is a graph given in polynomial. So I am finding it difficult to understand. Can you once explain the solution, sir, please?
If you have time, just wait for a minute. Let me open that solution.
Yes. Yeah.
Okay, just a minute. Yeah, so everything is important from exam point of view.
Yes, sir, this question.
So it's given that Px and Qx are two quadratic polynomial, right?
Yes.
So some part of Px, so graph of some part of P of x is given, and graph of some part of Q of x is given, right?
Yes, sir.
So from this part, you know that the roots of P of x is what? What are the roots of P of X?
P of X is 1
and D, right?
Yeah, 1 and D.
And what is the root of Q of X?
13 and D.
13 and okay, so it is given that the leading coefficient of P of X and Q of X is 1, and the y coordinate of the vertex of P of X is equals to the y coordinate of the vertex of Q of X. Okay, so this y coordinate of the vertex, which is more or less clear from the graph that they are same. Okay, then you need to find the value of D, right? So so you know both the roots of P of X, right?
Yes.
You know both the roots of P of X, 1 and D, right?
Right, sir.
And you know that the leading coefficient of P of X is 1.
Yes.
This is also given. Then what will be P of X? Precisely this, correct? You have two roots and the leading coefficient is 1. What will be P of X? X minus 1 and X minus D, right?
Yes, sir.
And what is the y coordinate of P of X? Y coordinate of the vertex of P of X. This is your P of X, right? What will be the y coordinate of the vertex of P of X? What is the vertex of a quadratic polynomial? Minus b by 2a is the x coordinate, right?
Yes.
And f of minus b by 2a is the y coordinate, right?
Yes.
And here f minus b is basically d plus 1 by 2, right?
Okay.
So if you substitute f of d, if you compute f of d plus 1, you will get this. Okay. Correct?
Okay, sir.
So similarly, you try to do it for Q of X, because you know roots of Q of X is what? D and 13, right? And the leading coefficient of Q of X is plus 1.
Plus 1.
Right?
Yes.
So now you can compute what is Q of X, right? This is your Q of X. Again, you compute the y coordinate of the vertex of Q of X, and it is given that this y coordinate of the vertex of P of X and the y coordinate of the vertex of Q of X are same. Okay. So now you equate it, and now you solve this equation. Is it clear now?
Okay. Okay. Okay, sir.
So the main idea is basically you are computing the y coordinate of P of X and y coordinate of QS, and it is given that both are same. So now once you equate this, you will get a quadratic equation, or here you are getting basically a linear equation. Okay, from there you can get, by solving that, you can get that.
Okay. Okay. Thank you, sir.
Okay, thank
Real question.
you.
So approximately how many questions will be there in the exam, and basically we have 1.5 hours to solve the paper.
So okay, so I guess more or less 20 questions.
Okay, sir.
So yeah.